sailor side, minds open wide, fringe heroes unite, secrets can't hide, 0 point dreams, they reach for the sky, gravity defy, ancient whispers abide. Welcome to the edge of what we know, where dreams they fly, let knowledge flow, in the cradle of stars, whose light will go, with Nathan and the band are back to watch the future grow. Vision, ride the light they sail, ancient forts unravel like comets glowing tail. Nathan lights the charge, circuits burn ablaze, will the benefactor all his curious maze. Echoes of old secrets whispered in the night, they guide the light to a future bright. Breakthroughs at the fringe they take, leaving dimensional science to draw a blank. The Fringe Think Tank, the scientific lens, Nathan, Ben and friends, the fun never ends. In the depths of the unknown, radio waves like dark shows, mysteries unrepacked and shown. Solutions defy what we know, hidden truths we're never alone. Follow me down the rabbit hole, secrets and binding codes, breaking the mold, define control. Power bursts without a soul in this digital catacomb. We scrap the truth of the truly bold. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Energy from the ether flow, quantum realms, the science of flow. Whispers from ancients echo, gravity's on hold, let's go. Beyond the reach of their woe, floating with you ever come, bridge the gaps, all light shows. On we roll, past the famous Saint Soul. This is all in our road. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Synth waves crashing, hearts collide. Revolution of the mind. Let the codes and truths unwind. Illumination find. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance.
Secrets and shadows, true quest to follow. Ancient designs, all lost to time. Minds of the blind, rulers of kind. Knowledge unknown, locked in the throne. Tear the veil from the lies, truth will rise. Break the chains from our minds.
From the depths of hidden files, trapped inside the secret circuits, unraveling through the miles. Oh, truth was masked by golden curtains. In it now, we're shattering the silence. Feel the power. Revelations on the rise. From the shadows, light emerges, breaking through the veils of dark. 0 points and gravity converge, yeah. Guiding voices, revelation start. Ancient whispers call. They're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power. Revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting us free. In this epic, we play our part with fierce hearts. In it now, we're shattering the silence. Feel the power. Revelations on the rise.
It appears we have a glitch in the system. What's going on, everybody? I'm the Benefactor, your friendly neighborhood independent researcher looking into the rodent coil, and today on our pregame show we are going to be going over some new interesting developments for phase 2 testing of our 0-point energy generator system. What's going on, Crypto, Sax? We got Misunderstood. Everybody's in the house. Awesome. Let me know if you can hear me. I'm going to just go over my settings real quick, make sure everything's in order. I have a couple of videos to show you guys while I charge up my camera here and get the system ready. I am going to be posting a preliminary research guide that will go over everything that I have on the Bedini circuit, how it's related to what we're doing with the rodent coil, and why the Bedini circuit is the one that I chose. And also it goes over some of the theories behind the Bedini circuit and how it works. It's a very simple circuit, so it's not too complicated to understand, but unfortunately, you know, engineers have this mindset and not very good communication skills. So I try to break it down for a general audience, a general reader, and I think I did a pretty good job of that. I'm going to put it in chat right now. So you can also follow along if you've been using the part 1 of my rodent coil guide. This is all still relevant if you need to know information of how I'm hooking up the coil and all that good stuff. Awesome. You can hear me? Okay, so this is the preliminary research guide for phase 2 testing of the rodent coil system. And again, it just goes over some of the basics of how the Bedini circuit works, what are its claims regarding you know, John Bedini's claims on the circuit and how it operates differently than other circuits. Just as a quick breakdown, I'll give you the basics here. Phase 2 testing was planned as an effort to combine two very easy and common free energy devices into one simple design that could be utilized for practical applications in energy generation and battery desulfation, or rejuvenating a dead battery. John Bedini referred to the process of restoring a dead battery back to life as desulfation. Over time, the lead-acid batteries can accumulate lead sulfate crystals on the battery plates, a process called sulfation. This buildup prevents the battery from holding a charge effectively and can make it seem dead. Bedini's battery chargers use pulsed energy. It's kind of like a hammer to break these sulfate crystals, restoring the battery's ability to charge and function properly. This process is known as desulfation. And the Bedini's SG solid-state circuit is essentially a system designed to charge batteries and extend their life using pulsed energy. You're using one battery just as a kickstart for the generation and collapse of electromagnetic field that creates the feedback. And the feedback is the back EMF. And normally that's grounded out, but here in the system, we're using the back EMF correctly, and we're putting it into the negative charge of the battery we're trying to charge instead of the positive. We're forcing it into the other way. I believe I have that correct, but we are putting it into the opposite terminal than it should be. We're forcing it into that opposite terminal. And it's like a hammer, as John Bedini describes, and it hammers the sulfate crystals off the charge plates. So the reason why I think this is going to be a good fit is because, well, up until now I didn't know this, but we did find an H-wave in our system, and the Bedini circuit is known to produce this H-wave. That's why it works the way it does, and how it works so efficiently without really using the power battery. It's using this H-wave and we found an H wave. So that leads me to believe even more that I've chosen the correct system to try to integrate here. I mean, if I can't do it with the Bedini circuit, then I don't think it's possible, because this is the most simplest circuit I could find. I wanted to keep it simple for everybody because replication is key here. I don't want to just make these for myself. I want everybody to make them, and I want everybody to see what they can do. And in order to do that, I have to make things as simple as possible. This is a zoom in of the H wave here. And here you can see John Bedini describes the H wave as that large spike, and then kind of a similar bump here. I'm not sure if that's relevant, but that's a zoom in of a part of the wave. So maybe it's a fractal, you know, where we see that kind of little bump fractally at different scales within the wave. Who knows? Yes, I'm going to show everything. Can this work on a 3.7 volt lithium? You know, I was asking Mike Does, and he's been helping me out a lot with this. He's been essential, actually, in this phase 2 development. So shout out to Mike Does. Yeah, he said that you need at least 12 volts, or it's gonna be too much strain on the battery. Like imagine, you know, using a large sledgehammer for a tiny pin, you know, size nail. It's just gonna hammer it too much and damage it, I guess, is the theory. So what we need ideally is 12 volt battery with 13 amp hours, at least 13 amp hours. And I think I found a good candidate on Amazon for about, believe it or not, $18. I'm not sure if it's legit. I still have to look, because, you know, every battery that I've seen around that power output is you know, in the 200 range. So yes, let's let me load up. Oh yeah, my bad. Let me load up the because if you guys aren't following along, I'm going to show it on the screen. Let me load up the presentation window. Preliminaries. There we go. Okay. All right, so now you can see this is the H wave that I found in my system. This, again, this isn't with the Bedini circuit, by the way. This is just with the stereo amp and the tone generator, just, you know. And this is a zoom in of that. Sorry, I was talking about fractals. This is a zoom in, and I was wondering if this little bump here was maybe a fractal within the wave, because we see this same pattern right here with that initial spike and then that same little two bumps, only on the inverse. So just something to think about. Yeah, the H wave is a concept John Bedini used in his energy work to describe a specific type of electrical waveform. In simple terms, it's a pulse of energy that behaves differently from a standard wave, like a sine wave, that are typically used in electrical systems. Yeah, I'll go over some of this. Again, this, if you are a Patreon supporter, I believe there's well, we have multiple tiers, but I believe it's the $5 and up tier. You can unlock this stuff early. You know, I release it as soon as I put it out for my Patreon supporters, so they have something to follow along with, and they get it early. So if you are a Patreon supporter, you get this guide. You've had it for, I don't know, like 3 or 4 days now. And you get a whole host of behind-the-scenes videos, stuff that we'll be going over today, you know, because I like to release everything, but, you know, I have them on a timed delay. So for my Patreon supporters, shout out to all you guys. Mike Morell, you're awesome. You know, you guys get access to this stuff early. So, and it helps fund phase 2 testing and then phase 3, which I have not talked about. And I'm excited to release information about phase 3, but not yet, not in this live stream, unfortunately. I'm going to put together a presentation for you guys soon about phase 3, but I need confirmation that the Bedini circuit's going to work first, or at least that we can take this mobile. Now, I do have a portable stereo amp board, a mini board, that I got that I ran real quick, and I confirmed that it works, so we're going to do some testing with that, and I'll show that to you guys, because that's going to help a lot in my live demos. You know, as I've said many times, I don't like to just keep this in my apartment. I like to show it off and explain how it works so people can get interested in maybe building one themselves. That's the idea here. So it's very exciting that this is going to work, because it's like this big, you know, as opposed to a huge stereo amp receiver that, you know, weighs like 10 pounds, 5 pounds, heavy as hell. Yeah, this is pretty cool. So that means I can take this, and it's going to be more portable for my live demos. All right, let's continue on with this preliminary guide, so you guys have some context and background information of what we're going to be doing with this Rodin coil system in phase 2. So the Sachs says, so the Rodin coil gives extremely too much power, but what if you make the coil smaller? I mean, if the hammer is good size for the... well, it's not just about the Rodin coil. It's the circuit itself. It's the H-wave. So I guess the idea is anytime you have that H-wave, that large transient spike. So let's go here. We can see... let me highlight this so I don't lose track of where I was. But see here, you see that large spike right there at the top, at the very start of the wave, and then it just dips down real fast before the two humps, before that H. That's the transient spike. That initial spike is what that radiant energy is. And that's the hammer blow to the battery. So, and that's what we want for the system to operate correctly. So unless we can use the system without that spike, which, you know, I don't think is going to be possible, no, I'd say we have to have a proper battery. John Bedini always emphasizes that you need to have at least 12-volt battery, preferably 24-volt, so you don't put too much strain on the battery, you know, because you could be doing other damage to the battery while you're, you know, knocking off those sulfates. Friend, does it work? If it does, then just show the results to those who don't. I haven't tried it yet. I need a battery. So right now we're getting the system ready for phase 2, but it is not officially in phase 2 testing yet. These are preliminary tests for phase 2. I'm testing different methods to take the system portably, and I do have a method to show you tonight. I'm going to let my phone charge because it's going to be the camera. I'm going to let it charge for a little bit more. I'll show you a couple videos first, and then we'll show you the new system and how I'm going to be presenting it from now on in front of live audiences. So let me show you those videos right now that I released on Patreon so you can get an update of my system and the preliminary testing that's been going on. Okay, so the first video I'm going to show you is me getting the system to work correctly with the pulse width modulator. Straight up just hooking the pulse width modulator to, believe it or not, a 9-volt battery. And we were testing how long the 9-volt battery would power my output circuit, the one with the fan, the rectifier, capacitor, and the 2 ohm resistor with 3 LEDs. Just a little simple circuit for output demonstration for the load. And so I got it working with the PWM, and we were inputting, I believe it was 2 to 3 kilohertz into the system, into the coil, and it was running for a little bit. And I'll show you the video. Let's see if I can get this loaded. Can you hear that? Let me see if I don't know if the sound's on. Oh, nope. There we go. Sorry about that. I knew the sound wasn't. Okay, Patreon crew, we got our PWM, our pulse width modulator, hooked up to just a 9-volt battery. I've been running a little bit, so it might be drained a tiny bit. But we are running peak 24 to 10 duty cycle, but it seems like to start the fan, we have to kick up the duty cycle a little bit. So we turn it on. It's hooked up to our circuit here through the coil. So we turn it on. Oh, I guess we had some energy in the capacitor, so it turned on fine. And we're at 24 high, 10 low on the duty. Real quick, Sax, just so you have some context here, I'm not trying to do a perpetual motion machine. And there's a difference between over unity and perpetual motion. Now, perpetual motion is the next step of over unity, and it is maybe the ultimate goal, but it is not the goal that I have here on this for this system currently. And the main difference I want to emphasize is perpetual motion requires at least 200% efficiency in a system. You have to have 200% efficiency to charge whatever you're charging 100%, and then have energy left over. Right? So you have to have at least 200% efficiency for the system to run it on in itself indefinitely. Right now, the max that I could see with my multimeters, now, there could be, inaccuracies with the multimeters, but in general, it looks to be about 150, 155% efficient. That is not enough to indefinitely run anything. And that's not what I want to do. I just want to make a highly efficient system that saves you a little bit of money, saves you a little bit of energy. That's all. And that's what we are seeing with this coil design. It is going to work well for us in that respect, because even our Fireball coil, which I haven't really been able to tune into the proper frequency like the Mark 1, but the Fireball coil still gets around I think it's around 70% efficiency, something like that, which is still pretty good, for a giant coil and no like tuning of the circuitry or anything at all, just with the raw ingredients. And look at this waveform. This is very, very interesting. Look at that. And as we adjust the duty, we're going up to 50. And it doesn't seem like 50s are optimal. We kick it back down to around 24. And then we get this nice peak. And you see that radiant spike at the bottom, the spike of negative energy. It's kind of like almost like an H wave on the inverse axis of the x-axis only. It's very unusual, but I suspect this is because we're only using half of the signal here. We're pulsing the DC signal instead of alternating the current back and forth. But it's powering the load quite nicely with this 9-volt battery. Yeah, and we're just gonna see how long that runs. Oh, the frequency is set to 1 kilohertz. So actually, let's adjust that and see what happens. See if we can kick it up to 2, which I think is the peak. With this, oh, it is at 2. Okay, my bad. It's at 2 kilohertz. Yeah, okay, so 2 kilohertz. Kick it up to 3. Oh, what's this? 4. Okay, so maybe 3 kilohertz is the peak. Look at that. Okay, we'll leave it at 3 kilohertz. Yeah, that just spiked up, and then I kicked it to 4 and nothing really happened, and then at 5 it went down. So that's how you know that's the threshold there. See, I'll kick it back down to 2. And look at that. Back up to 3 kilohertz. Again, we're on, I believe, 24 on the duty cycle. Yep. Look how it's
24
shaping
on
the
the duty.
waveform. These LEDs, we got 3 LEDs and a 3 to 9 volt DC motor here with a rectifier and a 50 volt, what is this, 1 unifarad capacitor, 10 unifarad capacitor. So this is doing quite nice. As you can see, it's at 2 volt, so it's getting close to 2 volts at the output, it looks like. So that's a mistake on my part. I was reading it incorrect. It's actually getting closer, it looks like, to 7, 6, 7, maybe 8 volts, something like that. I have to measure it correctly with the multimeter because this doesn't really give me an accurate reading. It just gives me an idea of the waveform. It's a very cheap oscilloscope, and the frame rate is very crappy. So when I put a lot of energy, and you see in this next video, I put a lot of, one of the next videos, I put a lot of energy into it, and the oscilloscope just struggles to keep up. There's so much data. But anyways, yeah, so that was a mistake on my part. My bad. It looks like it's getting at least 6 volts, 7 volts, which is interesting because when I tested the 9-volt battery, it was used a little bit. So it was only getting it slightly above 8 volts output. So if it's getting 7 or 8 volts output, that's extraordinary because it's using all the voltage, and we'll have to look at the current, but yeah, this is good news if we want a highly efficient system for sure. Keep the PWM in mind. But with the Bedini circuit, we don't need the PWM. It just does this H wave naturally. So with the PWM, we can it's kind of like a function generator in that respect, where you can kind of like play with the settings and try to manipulate the waveform a little bit. So a poor man's function generator. But only with pulse to DC only. It doesn't do AC, which is something that I think is the problem here. See, we're only getting the H wave on the inverse x-axis. We're not getting it on the plus x-axis. So I believe that, no, I'm sorry, that's the plus y-axis. Anyways, we're not getting the full waveform. We're like basically getting half of it. And that was my theory because, I was talking with Mike, and I'm like, okay, Mike, the PWM with the Mark I is getting about 75, 76% efficiency. It's not getting over Unity, but it's still doing pretty well. But I haven't looked at, at this point I hadn't looked at the waveform, but I had a suspicion it was only because it's pulsing it and not alternating it back and forth. It's only getting half of the signal that it needs to. And this just confirms it. It's only getting half of the signal. So, I mean, that more research is going to be needed I know there's a way to get the others to have the signal. Daniel and Erica Nunez did it. A few other people did it, and there is a way. We just have to play with the settings a little bit and maybe do some customization with the circuit, but this is good news. Very good news. Oh, and my point, by the way, when I was talking with Mike my system gets 150, 155% efficiency when I have it hooked up to the stereo amp receiver with the AC. And with this system, it only gets about 75. So that's half, right? And that's why I was thinking, it's, half. It's probably getting just half the signal. So just something to think about. Which, again, depending on how much energy we're actually using from this, could be a good thing. I tried hooking up the multimeters, and I didn't get a good reading on the the output circuit here. I got 0.7 volts on the output, which, I mean, it was reading like that at the other setting on the oscilloscope, but technically this shouldn't be going that fast at only 0.7 volts. especially with these 3 LEDs on, that doesn't seem right to me. So, you know, we'll have to do more testing in order to determine exactly what's going on. But this is a good sign for bringing this into the mobile range for phase 2 testing. It doesn't look like it, but I do have it hooked up as the transformer method, my own custom method, where you just hook up red to red, black to black. But I got the wires mixed up because I was, you know, in a hurry testing this out. Not 1, but 2 Bedini SG solid state circuits ready to go. This one right here. This one's got a nice heatsink. Yeah, so that other, here, let me show you, this other Bedini circuit that I made also has a little LED indicator attached to the load, which is the collector and emitter. So if you attached any kind of load, it would be on the collector and emitter of the transistor here. So this is just an indicator that it's getting power, just something for me visually to see, okay, you know, if it's not working, I can troubleshoot it a little bit. Okay, it's getting power, but it's not working. Oh, it's not getting power, so something's happening, right? So a little indicator is very important. Call it an idiot light, whatever you will, but I think it's important because I've tried to hook up the Bedini circuit without one, I tried to hook up a rectifier without one, and it was a mess trying to troubleshoot it. I couldn't get it to work. It was like a full bridge. I think I was doing a full bridge rectifier where I was trying to convert the pulsed DC signal into a full AC signal using like 4 of these transistors, and I couldn't get it to work. But I didn't hook up a indicator light, which I should have done. And you know, if I have time, maybe later we'll maybe give that another try. Or if anybody has a diagram for an easy, you know, like full wave bridge rectifier, I think it's called. I'm not sure if that's the correct term, but it's something that converts DC into AC signal, right? It just shoves it back and forth using, I'm assuming, at least 2 transistors. But the one that I looked up had 4 transistors, but I couldn't get it to work. Yeah, so I'm gonna run this for a little bit, and I'll get back with you on some further results for this pulse width modulator system. I let it run for a little bit, and it only ran for about 22 to 23 minutes. But I believe doing the math, and I tried to do the math with ChatGPT before, and it gave me like 4 hours. That didn't seem right. Like just running the battery on these circuit components and the fan and the components alone. But I didn't factor in the ohms, the resistance of the coil. So that's, once I factored in the resistance of the coil, the 8 ohm resistance, that actually brings it down to about, it said 22 estimated minutes for a fully charged 9-volt battery. Slightly discharged 9-volt battery at 8 volts to dissipate fully. So, I mean, I don't know. It seems like it could be a good indicator that we're getting a really good number. I don't know exactly what our efficiency rate is, but that's just something to think about. Let me bring up the second video. All right, just to compare, we have the reference circuit hooked up. Technically, that's the reference circuit, but this is hooked up as a reference circuit because, as you can see, it's not hooked up to the coil at all. It's directly just hooked up to the stereo amp, and we're taking a look at the waveform compared to the H wave we found when the coil was resonating the circuit load. So we go here, we're at 60 hertz, go to 1000, and I'll prove it to you. And look at this waveform, it's all jacked up. This didn't. So I got the order wrong. This was not the next video, but I can still show this to you because the next video is still relevant. So this is using the mini stereo amp board. Here, I'll rewind it so you guys can see. So I have stereo amp. There it is. The Drax or Drox 2-channel mini board. It's a mini stereo amp board, and it outputs 80 watts per channel. I'm not sure if that's peak or RMS, root mean square, but it's theoretically it should work, right? And it does. It works exactly how I need it to, and I'll show you guys in a few minutes here after the videos are done, once I get set up. But this is just the stereo amp hooked up to the Workbench power supply, because this requires a little bit more power, 12 volts to 18 volts I think it requires. Now, it did power up a little bit with the 9-volt battery, but that was slightly discharged. We'll try it again with maybe 2 9-volts, if I can get 2 9-volts in parallel, I believe. And we might be able to get this thing powered up without the Workbench power supply tonight. That's my goal. But as you can see, it's powered up by a Workbench power supply, and it's getting about 12 volts, right? I'm giving it like 11.9. I tried to get it as close as possible, but about 12 volts. And this is not hooked up to the coil. Just this output for the speaker is hooked up directly to the circuit. We're taking a look at the waveform compared to the H wave we found when the coil was resonating the circuit load. So we go here, we're at 60 hertz, go to 1000, and I'll prove it to you. And look at this waveform, it's all jacked up. This didn't really get any faster, guys. Look, it squared off the waveform a little more, but it didn't get any faster. See, we're at 1000, we'll go back to 60. Same speed, same speed. Lights didn't dim or get brighter or anything. So this is just further proof to show you that this coil is actually doing something important. It's acting as a one-to-one transformer one-to-one step-up transformer, which in and of itself is significant, regardless of the over-unity aspect. So we got it working with our Workbench power supply, this little Drock 2-channel 80 watt per channel mini preamp board, or mini stereo amp receiver board. We are resonating the coil at 60 hertz. Let's change it to 1000. And as you can see, the lights come on and we immediately get that radiant energy spike. My oscilloscope is kind of crappy, so I have to turn down the power to see it. See how slow it is now? Although it is kind of squaring out at the top, it looks like, unless I'm seeing it wrong. I hope it's not doing what this coil is doing, as where you increase the power and it just squares off at the top. It looks like it might be, but I don't know. Just an important note here, it wasn't. I just had it set to the wrong resolution. So at the Fireball coil, we've seen that radiant spike, the H waveform, at a very, very low power setting, like in the milliamps. But as soon as you get into the, millivolts. But as soon as you get into the volts, it squares off at the top and it just distorts the waveform for some reason. It appeared to be doing that, but no, I was just not zoomed out correctly, and you'll see in a minute. Either way, look at that. I can't even zoom out far enough for it. Let's try to go to... I'm trying to zoom out as far as I can, and it's just overloading the oscilloscope. Let's try to go to microvolts. $40 oscilloscope. I mean, it's nice. I'm going to get another one, actually, but, you know, it's just, you mess with it, and... Let's change that to 10 volts. And turn the power back on a little bit. You can see the H wave starting to form. Oh, and there it goes. It kicked on. There we go. Okay, yeah, so it's not rounding off at the top. It's still maintaining that shape. That is awesome. We're going to check out the reference circuit in a second because we do have a left channel that we can put our reference circuit in. And again, this gets
Do that tonight.
80 watts per channel. I'm not sure if that's peak or RMS, guys, but this is really good news. If we can get this working with a battery, then we'll be in business. So, more updates to come. Oh, look at that. Look at that. The waveform is as perfect as it was using our really expensive preamp. Let's try to change this to... There we go. Okay, so I thought the waveform was perfect. It doesn't look to be as perfect to me. I'm not sure. It looks to be slightly off compared to the one that we get from like a proper stereo amp receiver. We'll have to compare the different waveforms we get. I mean, we're still getting the transient spike and then kind of like that downward motion, right? But it's not as clear as the waveform that we get with like a Insignia RS2001, for instance, even though it outputs way more power. I don't know if that's because I can't play with the mixing settings and it's just, you know, like it's built for bass, so it has the bass up a lot. I'm not sure if that has anything to do with it, but definitely if it's able to at least maintain anywhere close to what we were receiving with the 155%, that's going to be good news. You know, I'll be happy, honestly, with, 110%. As long as it's over 100%, you know, we can kind of demonstrate something practical. And that's the goal here. Let's catch up on chat, see what everybody has to say. Better. Actually, this looks like it might be a little less perfect than the waveform that we're seeing with the stereo amp. So we'll have to study the waveform to determine exactly what's going on with it. I'll have to compare notes. I'll have to compare this waveform to the one on the stereo amp. But as of right now, it is running pretty efficient. Yeah, so we got it working, guys. All right, let me catch up on what everybody's saying in the chat here. Sorry about that, I'm not really set up good here. There we go. All right. A resistor ladder might help with scaling signal to scope. Yeah, I'm not sure what a resistor ladder is, but I think you're right. I need some kind of resistance to help scale the waveform properly. And Shanjax, I know you had ideas with the Bedini circuit that you sent me. I'd really like to learn more about that because I think that will help us for phase 3. Which again, I'm not ready to disclose yet, but soon. As soon as I put together a presentation, I'll tell you about phase 3. But yeah, you'll have to explain, or I'll have to look up what a resistor ladder is. But I think you're right. We need some kind of resistance to properly scale this waveform here. Biggest downfall is frame rate. Yep. Hard to see what's happening real time if there are fluctuations. Exactly. Yeah, the machine works perfect. You all about that bass, no treble. Yeah. Oh yeah, that's funny. Does the simulator link work? Should be animated. Simulator link. Did you send? Is that something you sent in my email? I must have missed it if it is. I actually was thinking about hopping on Crumb at some point tonight if I have time, and trying to put together the Bedini circuit in Crumb, which is a 3D simulator. It's not made to handle back EMF, but I'm still curious what kind of readings we get on the oscilloscope with the waveform, right? So maybe we can do that at some point tonight if we have time. But right now, I'm going to set up the system to show you guys the PWM and the DROX, the two different routes that I have right now on taking the Rodin coil system, the 0-point energy generator system, into a mobile platform. Phase 2 testing, what I like to call. Phase 2 testing is all about mobility. We want this to be practical. We want it to be usable. We want it to be enticing for people to build, because it is. It's quite honestly, in my opinion, the holy grail of physics. It is a system unaffected by the weight that it carries, right? This is the end goal of renewable energy and alternative energy systems. So, it's kind of frustrating, because I'm screaming at the top of my lungs here, like, hey, everybody needs to be building these. And nobody in the academic realms, at least, are taking it seriously. I mean, we have a lot of people don't get me wrong, we have a lot of people building these right now. We have a whole team of people building these, and I'm very, very excited about that, to see what kind of results, for instance, Mike Morskitz from his Rodin coil. But in terms of the mainstream YouTubers, the big YouTubers, I reached out to a whole bunch of guys, and everybody just either ignored it or laughed it out. So it's kind of frustrating. That's why I try to demo this off anytime I can get a chance. Anytime I can show it off in public, I try to now. So let it run away. Double inductor variant. Yeah, I do have, I did buy some batteries, some 9-volt batteries. So we will be testing the fan tonight, doing some timing, seeing how long it will power when resonant compared to not when resonant and stuff like that. That's going to be fun. I'm excited about that. So we're going to get a lot of research done live here on stream. As always, I try to open source as much as I can. I know there's some things I can't disclose at the moment, but suffice it to say, I try to share as much as I can with everybody so that they can replicate all of these things and be on the same page. Yeah. I mean, that's what I did. We had somebody reach out to me in chat, and he's like, "Hey, can you need to share this with somebody called Great Scott." Now, I'd never heard of Great Scott, but he's a big YouTuber, and he has a big Discord community. I went on his Discord community. I couldn't find his email. We found his email later, sent him an email. He didn't respond. Hopefully he sees, but honestly, email is a crapshoot because it gets lost. A lot of these bigger YouTubers, you can't email them. It'll get lost in a sea of emails. But anyways, so I reached out to the Great Scott Discord community, and they just called it fake science. So what I did was I went to one of their subtopics or whatever, and it's something where you can share stuff, and I shared the video, and I was like, hey, this video's here, information's here if you want it, but I'm out, peace. I'm not gonna stick around for ridicule, but it would be different if they're asking me legitimate scientific questions, which is what I wanted. I wanted them to be skeptical, but open-minded, like I am. I'm skeptical, but open-minded. Like, I ask questions. I'm like, how does this really work? But I'm open to it being possible. And when you're not open to it being possible, and you're confronted with some real science or some real, SHIT that can be doing some real stuff, your little tiny brain just takes a fart, and you result in logical fallacies. Ad hominem fallacies, attacking someone's character rather than their claims. You commented on the last video, but what exactly did you have a question? You could drop your question here. Or are you talking about somebody else on Great Scott? Great Scott's channel, maybe. Anyways, let us get ready. Oh, wow. I try to set up this stupid Rumble thing through Streamlabs, and it never works. It works fine on StreamYards, but it Doesn't seem to work on Streamlabs. That's unfortunate. Okay. So yeah, let me shut this off. We are going to, while I get set up here, go to a quick intermission. So I'm going to pull you guys to the intermission page, and we're just going to chill out and chat for maybe 5-10 minutes while I set this up. Oh, and by the way, if you're not familiar, we have a whole host of merchandise available. This is the Benefactor Beverage Containment Unit that you can buy right now and help support my research. Cheers. Ooh.
Imagine a world where time travel is no longer confined to the realms of science fiction.
Time travel.
It's possible, sir.
Where do you come from?
I'm from the past.
Imagine being able to plant crops in the morning and then harvest those crops that very night. Or how about healing a wound with a localized time acceleration device? A device that can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me to imagine this world. A world where time is no longer a constraint, but a tool. Remember Back to the Future? The flux capacitor is a fictional device from the Back to the Future movie franchise that was used to achieve time travel. According to the movies, the flux capacitor is powered by plutonium and generates the 1.21 gigawatts of electricity needed to create a temporal displacement field. Sounds like a giant load of fiction, right? The truth is actually a lot stranger than fiction. Let's explore further.
And you told me the whole story. You were standing on your toilet and you were hanging a clock and you fell and you hit your head on the sink. And that's when you came up with the idea for the flux capacitor, which is what makes time travel possible.
Hey, Scott!
I need your absolute attention for a moment. Please, pay attention to the video you are about to watch and see if you can notice the problem.
It's an interesting character for me. It's not necessarily somebody you'd think that I am right off the bat be playing. A lot of people say, you could play Truman. Sure. But it's like, it was a tough job for me.
Did you see it? Some of you might have even seen it, but don't know how to describe it. What you just witnessed was a micro-expression, and even though it only lasted a fraction of a second, it could tell us everything we need to know. A moment of contradiction between emotion and words. Robin Williams' last video interview was with The Talk in 2014. In the interview, he discussed his new show called The Crazy Ones, and shared some stories from his past. Here we see Robin in a moment of what appears to be slight joy, talking about playing Truman, and then a flash of extreme sadness. And it doesn't just happen once. These are clear patterns of behavior that are universal. Have you ever wondered what someone is thinking? I'm not talking about those sideshow scammers you see grifting in the strip malls, preying on the desperate. I'm talking about a way to really know what someone's truly feeling. If we were looking at the world through the lens of Dr. Paul Ekman, maybe we could have spotted this contradiction. Eastern Highlands Province, Papua New Guinea. A mountainous region of the Papua New Guinea highlands, between the upper reaches of the Ambulum and Okapa rivers. Dr. Paul Ekman, a renowned psychologist who specialized in the study of nonverbal communication and facial expressions, is just finishing up his second year studying the facial expressions of the four people when he reaches a startling discovery. From 1967 to 1969, Dr. Ekman was interested in their facial expressions and whether they were universal or culturally specific. He found that the four people had the same repertoire of facial expressions as people in the Western world, which further supported his theory that facial expressions and emotions are innate and universal. This research with isolated tribes helped him to further refine his theories and develop his understanding of how facial expressions work, which has been invaluable to his work on micro-expressions. Dr. Ekman recorded their interactions and studied their facial expressions while teaching them how to read emotions from Western faces. His work with the four people helped him to develop a comprehensive theory of micro-expressions called the Facial Action Coding System. Micro-expressions are subtle, fleeting facial expressions that occur within a fraction of a second and reveal a person's true emotions or feelings.
There are two kinds of facial expressions, a macro or normal expression, which comes on and off the face, usually in 2 to 5 seconds, and a micro expression, which goes on and off in a 25th of a second. Now, if you use slow motion or freeze frame, a micro expression looks just like a normal expression, but it's been compressed in time. It's an attempt to conceal true feeling.
These expressions can occur when a person tries to conceal their true emotion or feelings, and they can be a reliable indicator of lying or deception. Micro-expressions typically last for a fraction of a second and are often difficult to observe. However, with practice, it is possible to develop the skills to identify these subtle expressions and understand their meaning.
Here is the really interesting thing about Paul Ekman. I'm scared to be around him.
I was very kind of paranoid when he was around.
You just assume that he is going to just like peer right into your soul, and he's going to basically give you a printout of all of your bull.
To spot a lie using micro-expressions, it is important to look for inconsistencies between the person's verbal and nonverbal behavior.
Colleagues have touched on counterfeit goods, and I share their concerns very deeply. I'm also concerned about stolen goods. Mr. Bezos, are stolen goods sold on Amazon?
Just that with over 1 million sellers, I'm sure that it has happened.
For example, if someone is saying one thing but their facial expression suggests something else, it could indicate that they are not telling the truth. There are different types of micro-expressions, each corresponding to a different emotion. The 7 universal emotions are happiness, sadness, fear, anger, surprise, disgust, and contempt. Spotting micro-expressions of these emotions can be useful in detecting deception. In summary, understanding micro-expressions and how they work can be a powerful tool in spotting lies. It takes practice to become skilled in identifying these subtle facial expressions, but with time and effort, it is possible to develop this essential skill. Dr. Paul Ekman's theory proposes that facial expressions are universal and innate, meaning that they are hardwired into the brain and can be observed across different cultures, languages, and ethnic groups. FACS has been widely used in various fields, such as psychology, sociology, and forensic science, to understand the emotions, intentions, and attitudes displayed through facial expressions. You have to realize, the average person lies 3 times per 10 minutes of conversation.
The question is never simply if someone is lying. It's why.
For more information on micro-expressions and how to train yourself to become a human lie detector, visit Dr. Ekman's page linked in my YouTube description. For more content like this, like and subscribe to my YouTube and TikTok channels, and stay tuned for more. From everyone here at Beneficence TV, we wish you all a very Merry Christmas and Happy Holidays. Expand your minds and subscribe today.
Shadows sing aside, minds open wide, fringe heroes unite, the secrets can't hide. 0-point dreams, they reach for the sky, gravity defy, ancient whispers abide. Welcome to the edge of what we know, where dreams take flight, let knowledge flow. In the cradle of stars, whose light will go, with Nathan and the benefactor watch the future go. Love is a vision, ride the light they sail. Ancient forts unravel like comets knowing tail. Nathan lights the charge, circuits burn ablaze. Will the benefactor all his furious maze? Echoes of old secrets whispered in the night, they guide the light to a future bright. Breakthroughs at the fringe they take, leaving dimensional science to draw a blank. The fringe think tank, the scientific lens, Nathan, Ben, and friends, the fun never ends. In the depths of hidden files, trapped inside the secret circuits, unraveling through the miles. Oh, truth was masked by golden curtains. You didn't know, we're shattering the silence. Feel the power, revelations on the rise. Shadows, light emerges, breaking through the veils of dark. 0 points and gravity converge, yeah. Guiding voices, revelation start. Ancient whispers call, they're begging us to open our eyes. We stand tall, defying all their lies. Even in now, we're shattering the silence. Feel the power, revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting minds free. In this epic, we play our part with fierce hearts. You didn't know, we're shattering the silence. Feel the power, revelations on the rise. In the depths of the tell what we know. Hidden truths we're never alone. Follow me down the rabbit hole. Secrets and binding codes. Breaking the mold, define control. Power bursts without a soul. In this digital catacomb, we spread the truth of the truly bold. Epics we uncover, forbidden undercover. Rise against the silence, breaking through defiance. Energy from the ether flow, quantum realms, the science of flow. Whispers from ancient echo, gravity's on hold, let's go. Beyond the reach of their woe. Floating with you ever cold, bridge the gaps, all light shows. Rise against the silence, breaking through defiance. Synth waves crashing, hearts collide. Revolution of the mind. Let the codes and truths unwind. Illumination find. Forbidden undercover, rise against the silence, breaking through defiance.
Sorry about that, guys. Hope you can see that clearly. We are all ready to go. We're going to do some testing with the Drox mini board, the mini stereo amp board. And then we're going to do some testing with the PWM, specifically with those new 9-volt batteries I have. I'm going to test one without the coils in resonance and see how long I can get it to go. And then I'm going to test it in resonance and see how long I can get it to go and compare the two and see if we can get some kind of baseline. I know we can't get the hertz down to 60 hertz, which is really what I want to do, but the PWM doesn't go that low. I might be able to look up a way. If anybody knows a way, I can just hook up a resistor to a circuit or something that we can test that out. But I got enough batteries. I got like 6 of them. So we can test that out. I also wanted to test out the stereo amp with 2 batteries in the series, in series, and see if we can get the board to power up with a battery. Now, I'm not going to be doing any testing with the magnets, with the mini amp at this point, because I don't want to blow it up. But we could just assume that whatever tone we put in here is going to have roughly the same effect as the stereo amp, the Insignia, or actually the one that we most recently are using is this Technics, this nice Technics that I unfortunately blew 2 of the 3 channels for. Have to excuse my camera. Sometimes it disconnects, sometimes it shuts off the phone. All right, now we're going to hook up the reference circuit as well. All right, it appears we're all connected and ready to go. Wish me luck. So it appears to be working. It appears that at 1,000 hertz, the circuit hooked up to the coil is getting more power than the reference circuit that is not. However, at 60 hertz, the reference circuit is really struggling. I'm wondering if this is to do with the sound wave coming out of here, out of this particular board, because it's bumped up the bass, I believe, a little bit, because it does have a bass output. Or it could be because these connections are a little weak. As you can see, I'm going to back off a little bit. I don't want to touch them. They're live. But these connections right here, I don't have alligator clips for. So I just have them twisted around the jumper cable. But if you'll notice over here, so this is 60. I don't have anything on the power yet. Let me turn up the power. So you can see the reference circuit is struggling. I think it's the connection. But still, nothing's really, the fan's not powering on at all on the coil circuit as well. But as soon as I bump this to 1,000, immediately we get power. No power. But if I increase the power level a little bit, give it a little more juice. Oh, this is powering on now. Oh wow, look at that. Just slightly. And look at this. Hear how fast that's spinning? We're going to hook up the oscilloscope in a second, but it's working as it's expected. At least with the traditional stereo amp setup, so I'm pretty happy with these results. Again, we're only putting about 11.9 volts in, 0.97 amps. Let's try to decrease that, because I'm curious if we can get this system running on 9 volts. Let's see. Okay, let's put 9 volts. Oh, we might be able to get it to run on a 9-volt battery, ladies and gentlemen. Let's see. Let's see. Okay, so at 9 volts, it's running pretty good. So we're going to keep it at 9 volts. I don't want to overload the system too much, but look at that. I just want to show you guys this. 1,000 hertz is the resonance range of this coil. We have two outputs, left channel and right channel. The right channel is hooked up to the Rodin coil, and the output of the Rodin coil to this circuit. The left channel is straight up just connected to this reference circuit. And look at that. It's not, the fan's not spinning at all. The power is barely lighting on this side. And this is a mobile setup, by the way. If we can get this working with a battery, which we should be able to, this little board, this is a very portable version of our system, and it will do well for live performances and demos. Well, live demos. Because look at this thing. This thing is huge. This thing weighs a ton. You gotta lug around that big stereo amp. And then look at this tiny board that we're doing the same thing with. Let's try to mess with the frequency a little bit. Let's give it 100. Yeah, that's not normal. That's not supposed to happen. This isn't supposed to light up first. This tells me something's going on here with this circuit. It might be the connection. It might be the connection over here. Let's try a sine wave. Unless there's not enough power. You know what? Let's crank it up a little bit because this should be able to hold at least 13 volts. Oh, there we go. That's what it was. Okay. So it wasn't the connection. It wasn't getting enough power. So we get 13.4 because the board says 12 volts to 18 volts. I wanted to see how it would react with just 9 volts. Obviously, it's doing really good. We might be able to get this to work with a 9-volt battery. But as you can see, 13.4 volts. It just might be, that might have been too low for 2 channels. I might not be able to hook up a reference circuit like that. But 1 channel I might be able to. So immediately you'll see that the reference circuit turns on first. We're at 100 hertz. Let's kick that down to the wall socket hertz, 60 hertz. 60. Okay, and I'll turn up the gain, and you'll see that the reference circuit comes on first. Interesting, huh? Ah. Ah. Increase the power a little bit more. This is not even on. That's not even on. Look at that. That's on. All right, so let's change that. Let's lower this down a little bit so it don't blow the system. Okay, so we have that on, and this isn't on. Let's change this from 60 hertz to a resonance range of 1000. And let's change that to a square wave. We get a little bit more power, and immediately, look. Again, this is the portable mini amp doing this. This is turned on quite nicely. This is bright, but it's not on yet. I can put the juice to it a little more, and it'll probably turn it on. Let's see. Oh, there it goes. Turn it down. And it stopped. Not enough power. That's barely lit. And look at that. Look at that beauty. Beautiful. All right, so we're going to take a quick break. Not an intermission. I'm just going to go over to the workstation because my lab is separate. And I'm going to catch up on chat, answer some questions, and prepare for the PWM. That should be fun. Yes, I know the audio is going to be a little bit low when I'm in the lab. I apologize about that until I get a better setup. Hey Sears, how you doing? Great to have you here on this Free Energy Friday. This is exciting, an exciting time in my research, and I know in your research as well. So it's great to have you here. I'm not on StreamYard, so I can't invite you on, unfortunately, but be prepared. Mike K from Faraday Research usually sends us out an invite, usually around 8:30, for a 9 o'clock podcast that we call the League of Extraordinary Inventors, and that's going to be a lot of fun. So, but this is our pregame show. It's almost 7 o'clock now, so we got a couple of hours until Free Energy Friday officially kicks off. Let's go to the talk room.
Hello everyone, welcome to Beneficence TV Live.
There we go. All right. So I hope you guys have been able to catch up a little bit with the Phase 2 preliminary guide here on the Bedini circuits, because that gives you a good background and a good context of what the system is exactly capable of doing if we can get it working, right? If the claims of the Bedini SG are true, which I believe they are, otherwise I wouldn't be investing so much time in this. I mean, yeah, of course, there's some part of me that wants to confirm it, and, I'm not 100% sure, obviously, but I have talked to a couple people who claim to have made these circuits. They're very simple, and I'm inclined to believe them at this point. I have no reason not to. So I'm really optimistic, because just specifically the waveform kind of confirms it. The coil and the Bedini SG circuit are going to be complementing each other on a level that I think is going to I think we're going to be able to utilize in a practical way. And it's very exciting. Phase 3 testing, thinking about it, is it's very exciting, and I can't wait to update you guys in Phase 3. But for now, let's open up the preliminary research guide for Phase 2, and I'm just going to go over a couple of things real quick. All right. So it's time we learn a little bit about John Bedini's theories on back EMF and this H wave I keep talking about. And it's something that I want to explain because it's very, very important to understand how the system's going to work and what to look for, markers in the system, to make sure that it's going to work. Now, as hard as I tried, I couldn't get my system to work with the trigger circuit. So I just had to disconnect it and use the PWM straight up, but that, I think that works well enough. So, all right. So on with the H wave. The H wave is a concept John Bedini used in his energy work to describe a specific type of electrical waveform. In simple terms, it's a pulse of energy that behaves differently from the standard wave, like a sine wave, that are typically used in electrical systems. Here's a breakdown of what the H wave is about. Unconventional energy flow. Instead of flowing like a typical alternate current or direct current, the H wave involves a kind of sharp transient energy spike that Bedini believed could capture or release more energy than usual systems do. This is that spike of back EMF. Radiant energy. Bedini associated the H-wave with something called radiant energy, a type of energy he claimed could be harnessed from the environment. When the H-wave occurs in his systems, it supposedly allows the device to draw in extra energy from an external source, like the vacuum or the environment, whichever you prefer, which isn't fully accounted for by conventional science. Energy efficiency. Bedini's idea was that the H-wave could help his system achieve what's called over-unity, where the output energy seems to be greater than the input energy. He used this waveform, the H-wave, to make a device like his battery chargers more efficient by pulsing energy in a way that was different from traditional methods. In short, the H-wave is a type of pulse that Bedini believed could tap into hidden or unconventional energy sources, leading to more efficient or even excess energy production. Now, this is half of the lecture for this evening, and the other half is how back EMF plays into this. Okay, so this is very important too to understand. In John Bedini's theories, he saw back EMF, or electromotive force, which is typically regarded as waste byproduct in conventional systems, as a source of radiant energy. In standard electrical engineering, back EMF is something to be grounded out or minimized, as it usually opposes the current in a circuit and causes energy losses, particularly in motors and inductive loads, because they're out of resonance. They're not resonating at the correct frequency, right? It's opposing and it's creating all that friction because it's not at the correct frequency. It's not resonating. Let's take a look at a simple breakdown of Bedini's approach to circuits. Back EMF equals radiant energy. Bedini viewed back EMF not as waste, but as a form of radiant energy that could be harnessed. He believed this radiant energy came from the environment, or the vacuum, what some refer to as zero-point energy. The H-wave in Bedini systems is the manifestation of this radiant energy, particularly in the form of a sharp pulse or spikes that occur when a coil, like his motor or charger designs, is pulsed in a specific way. Instead of grounding out his energy as waste, Bedini designed circuits to capture and recycle it. Harnessing the energy. By using techniques to capture this back EMF pulse, Bedini believed he could increase the efficiency of his systems, achieving what some would call over-unity. In practice, this meant using the sharp spikes of radiant energy from back EMF, like the H-wave, as a driving force of his motors or charge battery. Now, I was thinking maybe the H-wave isn't the only wave, and it probably isn't, that could produce over-unity and tap into this radiant energy, but this is what we're getting with the Rodin coil, so I'm rolling with it. Okay, so yeah, you get the gist. The gist is, most conventional systems consider back EMF. The energy, for instance, that comes from a collapsing electromagnetic field when it's pulsed, it's on and off, and then off the field collapses and creates all this back energy. That's energy drawn straight from the vacuum, and it's just grounded out because systems aren't, to be quite honest, built for it. It's a lot of energy, and it blows components, as we've seen time and time again on this live stream. On this channel, I've blown 3 stereo amp receivers and 2 channels out of 3 of the new one. All right, so in conventional science, back EMF, or the electromotive force, or the back electromotive force, or the reactive, it's a voltage that opposes the current in a circuit, essentially. And what is voltage? Potential. What is the vacuum? Just a giant sea of potential, DC energy at rest. So this voltage opposes the current in a circuit. It's negative voltage, basically. And that's why we see it on the bottom side of the oscilloscope. It happens mostly in devices like motors and coils, especially when there's a charge in the flow, change in the flow of electricity. Here's an analogy to make it easier. Imagine pushing a child on a swing. When you push the swing, it moves forward, and your push represents the electrical current flowing in a circuit. However, as the swing moves forward, it naturally pushes back against you a little bit. That's like the back EMF. Similarly, that slight hang time when you throw a ball high in the air and it hovers just before gravity sets in is also analogous to finding the 0 point in your system, where it is unaffected by the weight that it carries. And many thanks to Victor Sears for this analogy. This is a brilliant analogy, and Victor has time and time again blown our minds with his theories. Like just last time he was on, he talked about 3 different topics that blew my mind in a very prominent way that I had to like sit back and think about them. But great scientist. We call him the mathematician. He really is amazing, and I hope to see him tonight on Free Energy Fridays. There's just a big shout out to Victor Shears. Okay, so in simple terms, when you run electricity through a motor or coil, that flow of electricity creates a magnetic field, right? When the motor or coil stops or slows down, that magnetic field collapses, and this collapse generates a reverse voltage or back EMF. This reverse voltage pushes against the direction of the current that's flowing, making it harder for the current to keep flowing. This is the Lorentz law. You know, that any change in electromagnetic field is going to oppose the current, creating it. In motors, this is the main problem why conventional scientists and academics just can't see how this is possible. But I'm breaking it down as simple as I can, so kind of try to bridge that gap here. And just on the off chance any academics are watching or, official electrical engineers, this is, it is eye-opening stuff. But in order to understand how my system is doing what it's doing, this you really have to grasp. And I have to emphasize all of this because the more I study John Bedini's work and how he explains things, the more I understand how this coil is doing what the F it's doing. All right, so in motors, back EMF happens as the motor spins. The faster it spins, the more back EMF is generated, acting as resistance to the power that's driving the motor. I'm assuming because the motor's pulsing on and off. In inductors, the coil, in inductors and coils, when you suddenly cut off the power to a coil, like turning off a switch, back EMF is generated as the magnetic field around the coil collapses. It's like the energy trying to push back as the flow of electricity changes. And that's something I honestly see. I saw it last night when my battery was completely drained. It wouldn't power the circuit at all. It was just enough to power the PWM, right? Just enough to power that pulse width modulator. But it wasn't enough to actually make it do anything. And what happened when I turned the pulse width modulator on and off? When I turned it off, it had a spike of energy. When I turned it on, it had a spike of energy real quick. Pulsing it on and off, you get that spike of back EMF, and it lit up the lights for a second. That tells me, that just tells me right there. That's more evidence. And as I'm recalling the story that just happened last night, now in my head, I'm thinking about it. I was like, yeah, that's more confirmation of what's going on here. We're using the back EMF. It's a spike as you turn it off. It's effing mind-blowing, ladies and gentlemen. All right, to continue. Why does all this matter? In many systems, back EMF is seen as waste energy. It can even damage circuits if not handled properly, as I've demonstrated before with my stereo amp receivers. The fried and find out approach that Nathan likes to employ. Conventional systems often ground it out or use components like diodes to prevent back EMF from causing problems. In summary, back EMF is an electrical kickback or resistance that occurs when the flow of electricity through a motor or coil changes. the Lenz's law here. But we are reversing Lenz's law, okay? And we'll get into that in future streams. I'll give a lecture on reversing Lenz's law, and I've tapped into this a little bit on a previous live stream when going over the Practical Guide to Free Energy Devices 2017 edition and what they had to specifically say on the subject of reversing Lenz's law. And if you want, you could go back and take a look at that. I believe the live stream is called Reversing Lenz's Law. Yeah, we'll get more into that in the future, because that is significant here too. But we really have to grasp this concept of capturing the back EMF and utilizing it in a practical way. All right, so my assessment of all this, and this is just my breakdown, how I understand it. When you pulse a coil, the rapid change in the electrical current flowing through it creates a magnetic field. As soon as you stop or change the current, like turning the pulse on and off or AC, that magnetic field collapses, which generates back EMF, a voltage that opposes the direction of the original current. So that's just a quick breakdown summary of what's going on. And here's how it works step by step. Current flows through the coil. When you pulse electricity through a coil, it creates a magnetic field around it, right? Pulse turns off, right? You have an on and off phase of the pulse, obviously. You know, you have an on and an off. When the pulse turns off, you suddenly stop. When you suddenly stop or reduce the pulse of current, the magnetic field around the coil begins to collapse. Collapsing magnetic field generates back EMF. As the magnetic field collapses, it creates a reverse voltage or back EMF in the coil, pushing against the direction of the original current that created that field, right? You're putting electricity into the coil, right? It's going into the coil. You're creating this bubble of energy, this electromagnetic field, and that electromagnetic field collapses, creating a spike of negative energy that goes back into the system, opposing the current going in, right? And that opposition creates, resistance, friction, whatever, creates heat, loss, because it's not being resonated, right? It's not being alternated in the right frequency to resonate with the cavity that's carrying it, right? The conductor. All right, so when coils are pulsed, the sudden change in current causes back EMF, and that back EMF opposes the original flow of electricity. In most conventional systems, back EMF is considered a nuisance, but Bedini sought to harness this back EMF and its radiant energy instead of letting it go to waste. All right. And Lenz's law, that just is basically, any energy created by a magnetic field is going to oppose the, by changing a magnetic field is going to oppose the current creating it. We've gone over that. And this is a little bit of a breakdown of Bedini, Dollard's, and Tesla's idea of radiant energy, or the aether. Some people call it the ether. I call it the aether because ether sounds too much like the fuel, and aether sounds cooler, quite frankly. But that's just a personal preference. Aether and radiant energy. In these innovators' theories, they often referred to an unseen medium called the aether, a sort of invisible energy field that surrounds everything. Tesla called it the lumiferous ether. When you pulse a coil and the magnetic field collapses, they believed this collapse could interact with the aether, generating what they called radiant energy or cold electricity, right? Because when you're alternating at that negative energy at the right frequency, you're eliminating the resistance. You're reversing Lenz's law. There's no heat. It's cold. Not to say that it doesn't get, warm or whatever, but it's not going to get hot and build up that heat with loss like a traditional system. This is different from regular electricity, like hot electricity, because it behaves more like a flow of potential energy, rather than current with resistance. Again, potential energy. It's just potential energy here. And that's what Nathan likes to emphasize. It's just potential. You got to wrap your head around that. It's just potential. And what another thing to emphasize is, what is the aether but a giant sea of potential? That you can just imagine the aether as a giant blanket covering everything, a giant field that connects everything, and it's just a bunch of potential. It's DC energy at rest. When direct current is at rest, where does it go? It converts back into the aether, into that potential. Right? Energy cannot be created nor destroyed. That part is true. So instead of treating back EMF as resistance or waste like conventional science does, these innovators saw it as valuable energy. They were studying it. Why is this happening? Why do you have this spike of energy that we need to ground out, and it's destroying all of our crap, right? Oop, I just destroyed my crap. Okay. When you pulse the coil and the magnetic field collapses, the back EMF, which they considered as radiant energy, is not resisted if properly captured, because this, and that's the important thing to note here, is properly captured. Right? It's not that hard to create back EMF. Any old fool with a guitar amp can do it. but to actually capture that properly is an entirely different thing. But it's, it turns out it's not that hard to do if you listen to what Bedini says. And it's because this energy comes from the outside the conventional electrical circuit. That is, that's the reason why it's not resisted, right? This energy comes outside the conventional circuit. It's created from the ether. And because it's created from the ether, it's not confined to the same conductor, right? It flows in all directions, and you're just happening to catch the I guess you call it lines of electricity or negative energy through your conductor, right? It's not confined to the conductor and traveling where the conductor goes, like the electricity, as I understand it, at least. I could be wrong. At the end of the day, these are all theories. Correct me if I'm wrong. I'm going to take a break here in a second and answer some questions in chat. I just wanted to finish with this second part to the lecture here, because these are all important things to emphasize if you're wanting to replicate my experiment and do your own research and actually study this and find out why it's doing what it does. All right, so they claim that this radiant energy doesn't face the same kind of resistance that normal electrical current does in wires, because it's a different form of energy, more like potential energy or voltage spikes that moves quickly and freely, rather than through conventional resistance causing current. Like Nathan likes to say, it's just pure potential. Yes. Why no resistance with radiant energy? Normal energy or current, when it flows through a wire, it faces resistance because the electrons bump into each other in the material of the wire that generates heat and waste. But radiant energy or cold electricity, according to Bedini and Dollard, this form of energy doesn't face the same type of resistance because it's more like a potential energy spike that interacts with the environment or the aether, and it doesn't rely on the physical movement of electrons, so there's no heat loss or regular resistance. Remember, it doesn't follow the line of current that the current is confined to. It just goes in all directions. That when it's created, you create that 0 point, and like Marco Rodin likes to say, you create that 0 point and the energy just emanates out radially in all directions, or I'm sorry, literally in all directions, right? So I believe this is what's happening. And they suggest that radiant energy moves freely without the constraints of normal current, which is why it doesn't generate resistance. And this just explains on a very basic level, as easy as I can understand it, and explain it to you guys, how it's doing unconventional things that normal science fails to explain. And when science fails to explain something extraordinary, where do you turn? You turn to your friendly neighborhood benefactor to provide you with this amazing and very vital information. So with that, I'm going to take a quick break and answer some questions in chat. Yes, hey Gerald, how you doing? What's going on, guys? It's good to have everybody here. So again, I'm not on StreamYards right now, so I can't invite you guys, unfortunately. But the reason I'm not on StreamYards is because later Mike is going to be having, I believe he usually does on Friday, League of Extraordinary Vendors, and he doesn't have an a paid account, which means he can't share the ability for us to share the stream on our channels. So what I do is I just I capture it on the Streamlabs, and I put it on my page because you guys are awesome, and I want to provide you with these awesome podcasts that we do as much as possible. And it's unfortunate that Rumble didn't work out. Again, every time I use Rumble and Streamlabs, it doesn't want to start for me. Excuse me, my voice is going rasp because I'm talking so much. This is so exciting. I'm so excited. This is like a very exciting time. Like Gerald likes to say, it really is the year of the coil. And cheers to Gerald and Victor Sears. We have them both here in house. If you guys have any questions, they are both experts in their respected fields. And we got Lulu here. Oh, nice happy family. All right. So, I don't know. You guys tell me. You have any questions, comments, concerns? Oh, by the way, the reason I didn't have the oscilloscope hooked up earlier is because it's charging. I forgot to charge it. So it's actually, let's see what kind of charge it's got right now. Oh, it's fully charged. Okay. So the oscilloscope is fully charged. I had to, it charges pretty fast. Cool. I had to charge it up. We're going to take a look at the waveform in a minute on the PWM. I'm not sure why water is wet, but I can tell you that it is definitely not green. Or you got a definite problem with your water. Has anyone made an update coil frames? So Mike and I have been talking. He's working on a version 3 for the 432 Vortex coil, the PoE coil, right now as we speak. He's doing some testing with some string, which is pretty brilliant, to see how long and the winding pattern. I believe it's like I think it's going to turn out to be 3 channels, and instead of stepping it over 1 and up 1, we probably have to step it over 1 and up 3. That's just how we think it's going to go. Again, he's doing research on that, and I haven't had an update from him. I'll see if I can get an update on that because I'm kind of curious as well, see how it's going. But yeah, he's working on the version 3 Vortex coil frame. That's going to be really cool. And he also put out a coil frame that it's an attempt to replicate the original version 1 PoE Vortex coil from First Stop Energies. It's got the big long spokes, so it's easier. It should be a little bit easier to wind than the Dragon 7 one that I have. But again, I have so many of these coils I want to wind, and the limitation right now is the funds to buy the frames. I'm going to get in contact with Nathan. I think he can help me out with at least one more coil frame. He said he would be able to print a smaller one out, hopefully. We can get that adjusted and wind that one up. Because I want to replicate the Mark 1. So since I'm not getting the results that I was expecting with the Fireball Mark 2, I want to try to either rewind the Mark II Fireball coil at some point, and or also wind another Mark 1, because that one's a little bit smaller, the spacing is a little bit tighter, and also the gauge on that one is 23, so it's a little bit thicker gauge as well. Yeah, I have been hitting up Facebook Marketplace for my stereo amps. I got a connect, a guy who's got a couple more really nice ones for really cheap. When I'm ready and I have the funds for another stereo amp, we are going to re-up on that as well. And I am going to look in to see how much it's going to cost for me to send this Technics one, this nice one, to a repair guy. And I just don't want to throw it away, you know, and I'm not experienced enough to know how to repair it myself. And I don't have the time, quite frankly. I'm too obsessed with the Rodent coil system I have. So I think it's just a better option to set it aside for now and see if anybody can repair it for me. Benny with the goods. Yep. I got a whole bunch of merch in the Streamlabs merch shop, guys. I got t-shirts. You can see the patterns. T-shirt I have on. So the merch button, if you go to the description of my YouTube channel, I'll actually post it in chat right now. Give me one moment. Yeah, I'm going to post that in the chat along with my Patreon. If you guys want to stay up to date on my research and also want to help out with funding, you know, $5 a month or even $1 a month, it helps out significantly, and I appreciate all of it. But I did recently add a $1 a month option for the budget enthusiasts who want to just get, you know, who like Divine Science, you know, like my shows that I produce, the animated ones, you know, I think they're fun, and they do cost money. So, you know, like if you want to get those, like, you know, 5 days early or whatever, I'm going to try to put them out at least a week early for you guys on Patreon. The next one is going to be the first episode of The Benefactor's Guide to Free Energy Devices. The script is almost completely done. Basically, it's all ready to go almost. I'm ready to put it up in Adobe, but I just need to get the funds for the animation, that's all. And that, I want to try to have up, I want to give myself at least 2 months to get that one. I don't want to get too stressed out about pushing it out right away, but I think that's enough time for me to get that done for you guys. So be prepared. That's going to be on the Rodent Coil, and it's going to be a comprehensive, fun, highly produced, scripted, animated video, you know, that's going to go over all this fun stuff about the coil, from the background of it and all the way to, you know, how to make it and how to hook it up and what it could be used for and all that fun stuff. Let me put my information in the chat. So this is my Patreon, and then this is my Streamlabs merch. And if you would like to also generously donate and help fund my research, here is my Cash App and Ko-fi. You know, as you can see, I'm in a 1-bedroom apartment with a mini lab here. I don't have a lot of funds to work with, unfortunately. I want to do some cool stuff with this, so hopefully we get some help out on that front. As I've said before, the benefactor needs a benefactor. Yeah, people keep asking me, well, why don't you do this and why don't you do that? Well, you know, like well, time is a factor one. You know, I have a full-time job, but, you know, money is also a giant factor with a lot of our research. And I know a lot of other guys are, you know, in that same boat. So it's just unfortunate. It's the way we live. Where was I? Oh, yeah, I was going to... yeah, let me show you these clips real quick, because I got a couple of clips from Bedini, that specifically talk about some very important parts that regarding the topics we just discussed with the H-wave and the back EMF and all that, and specifically how it applies to what we're going to be doing with the Bedini circuit. So let me load that up for you guys. Grab your popcorns. It's going to be I'm not going to play the whole video, obviously, but it's going to be a short clip. Okay, there we go. So this clip, real quick before I jump into it, is going to tell us how to troubleshoot our circuit. It's going to tell us what we can do, a simple thing that we can do, putting this resistor here to test it and make sure it's working. Oh, my bad. Audio's missing. Let me rewind that for you guys.
To test this is put a 1 ohm resistor, take this battery out and just put a 1 ohm resistor here in between these 2 points. And if you are developing current, your machine is running incorrectly. All right.
Have you got any notions as to why it would be producing current? Why it would be, what would be incorrect?
Yes, something would be staying on here. Okay. Or this would be at much too low of a resistance, or this transistor would be leaking, or the diode's leaking. So since we don't know what components they're going to use, I can't answer the question of which one's going to leak. So.
But these are common.
These are common things.
Yeah.
So let's look at our motor again. Let's look at the real motor, so you can see exactly what we're after here. Okay, I'm just going to use the one that we built. I'm going to turn it sideways like this. I'm going to show you that if I disconnect the output battery, the signal that I'm looking for is right here.
So that would be battery B you've just disconnected?
Yes. I'm looking for this. I've got neon lights here so you can see the high voltage that I'm looking for. And you can hear it. Okay, now, notice when I walk around the machine, I want you to see here that the high voltage does occur. You see it here? So when I connect this up, well, I'm going to demonstrate something to you first. We'll stop the motor. And we'll just take these light. We won't face them towards the camera.
That's okay.
This is a 13 amp hour battery.
So as you can see, there's a simple way to troubleshoot and see, oh, okay, our system's not working because something's leaking in the system. This is also a method recommended by Mike Does, is attaching, let me go back and, okay, so attaching these high voltage LEDs or high voltage lamps. I don't know exactly what they're called, but they're used for detecting high voltage. They'll light up. And this,
we're getting this spike.
This is on the H wave. This is what Bedini has to say, his own words on the H wave.
And it's going like this. And we're catching this energy here.
And look at that. He's catching the positive spikes. And look at what we got real quick on my circuit. Do I not have the picture in here? Here, let me load the picture in here real quick for you guys to see. Oh, it's not a picture, it's a video. Let me put up the video so you can see side by side exactly what we were getting with the pulse width modulator. Okay, Patreon crew, we got our PWM, and then we get this. Oh, there we go. Let me just screenshot that actually real quick and put that in our guide. Okay, so look at this. You can see the H waveform on the bottom on the inverse axis, right? On the negative spike. But it's not on the positive spike. Again, this is with the DC, pulse DC. This isn't with the AC, which we normally get the over unity. I mean, it was still getting pretty efficient results. But I don't think it was exactly what we were looking for. And I think this just confirms it. He's capturing the spike on the positive side. And as you can see, there is no spike on the positive side, right? It's more of like a rounded square on the top. Very interesting. My theory is because we need to alternate it as well, so maybe this might not be enough. You know, maybe we could try adding alternate current to this somehow, changing the waveform a little bit. If anybody has any ideas how we can do this, and flip this H wave and reflect it on the top axis, like I have up here with the stereo amp receiver right there. See that? If anybody knows how we can replicate that, then let me know, because that's kind of an impedance right now in the research I'm doing, and it would be greatly appreciated if anybody had any insight on how to change this to this up here. So just reflecting it basically on the x-axis so that the H wave is on the top as well. And again, I'm pretty sure this is because this is a pulse DC and not alternating current like we see with this setup. So let's go back to what he has to say about the H wave.
We don't care about this because it's at 12 volts. And 12 volts could only divide between the two batteries. If it was leaking through there, you would get a little bit of charge in each battery.
So what's the maximum voltage of the spike?
So the maximum voltage of the spike is over 90 volts because these lights are coming on and killing it at 90 volts because we don't want to blast a hole in these transistors.
So the neon lights actually curtail?
They're bringing it down to a 90 volt. In other words, if it goes over 90 volts, the light is coming on, the gas discharge.
Okay.
Because I'm only interested in these spikes. I am not interested in a current meter between this and there because I'm not dealing with current here. I'm changing the form of energy. I'm asking the machine to do work, which it's doing with a fan. That has to go into the equation. The work must go into the equation.
And again, for anybody who's not familiar with my research to this thus far, this is the same circuit he's using. He's using a Bedini SG circuit. He's just using the flywheel version. As I believe it, there's I'm using the solid state that Mike does recommended to me, which doesn't use this flywheel. It doesn't have to. It just uses a coil, and we're going to be replacing this pulsing coil that's producing this electromagnetic field and collapsing and producing and collapsing. We're going to be replacing this coil right here with a Rodin coil, and we're going to specifically see if we can bump up the efficiency. I predict that we can. I think that we can, and I have some pretty interesting ideas for phase 3 testing if we can, but again, I'm not ready to divulge that at this moment.
The machine is doing work. While it's doing the work, I'm asking it to recharge its battery that we just depleted with the lights. Now, there's no other way around this. We've taken this battery, we've drawn all the power out, so this is not trickery. And because you can see if I take this lead off, the lights come back on. And look over here. It's really there. So now what I'm telling these spikes to do is go hammer the battery here and move the ions backwards as if the battery wasn't used. Now, how do I know that it's working this way right now? Very simple. Because that would never recover that fast in your car. But remember that it's going to take time to put all the energy back in that battery.
Right.
So this is how I know that it's working.
We have one more clip.
John, what are the some of the most common mistakes that people make? The top three, top
The common
five.
mistakes are magnets, number one. The spacing, number two.
Spacing between what?
You want the spacing to be about the thickness of the magnet. See? I don't want to really stop it because I want to.
No, I got it right
I don't
here.
want to deplete them. I want it to go ahead and charge the battery, but I want it to about the spacing of these magnets. They're about
Oh, the spacing
Yeah.
between the
Yeah.
magnet. Yeah. Okay.
Yeah.
Okay, not the spacing. Yeah.
the spacing, and the magnet space. The thickness of the magnet is about the space you want between the pole and the magnet.
Right.
Yeah, yes, right. And that will put you in the ballpark. You might have to adjust a little bit one way or another way. The next mistake people make is they start out with a 10 ohm resistor because they can't get it to spin because they use neomagnets. And then they get on the group, or they get it, or they call and they say, I can't get it to run. It burned out my transistor. And then I said, well, what do you use for magnets? And they go, neomagnets. That's a misconception, because a neomagnet's not exactly what you want for this kind of motor. So, next mistake.
What exactly is a neomagnet?
A neomagnet is a neodymium iron boron magnet, one of these things.
I wonder if that's because the magnetic
tough
field
little
is too,
magnets.
or the EMF is too strong.
It's an iron boron magnet. It's known as the General Motors magnet. And we don't want this, because this is an iron magnet.
Neodymium.
Yeah. We don't want this kind of magnet. This kind of magnet, when you put it next to aluminum like this, it becomes magnetic.
Okay.
Okay, there's too many field lines, and it's going to saturate this core.
Oh yeah,
And it's gonna
oversaturates it.
A lot of current
This is finished.
to get this up. Okay, but one of the other questions that I get all the time is, well, it's a generator.
Yeah,
isn't
heat.
it? No, it's not a generator, because if it was
Fries
a
the
generator,
transistor.
I couldn't spin it like this and take the outputs.
What's up, Nathan? How you doing? It's good to have everybody here.
And go like that, it wouldn't continue to rotate. It'd stop.
You wouldn't get the sparks
Right.
either.
I wouldn't get anything. If it was a generator, it was rotating this fast. You don't see any sparks at all.
Right.
But when you turn it into an energizer with the trigger, then you get this different form of energy. And I'm telling you all right now, it's a different form of energy. Battery A is not battery B. Battery B cannot go where battery A goes, because they're two different forms of charges. Battery B performs like battery A with lights, motors, inverters. So you could take an inverter with battery B and run it to A, because it's the same kind of electricity. That's the other question that I get. The other question that I get is, why can't I use a bolt? Well, you can't use a bolt in here because you're gonna take the magnetic field and make it heat. It's gonna require more current to make this machine operate at its resonant speed that you see it doing.
So can I ask a question then on that little drum you've got there with the wire wrapped around it?
Yes, the
Where-
coil?
Yeah. Where are the rods down the middle?
Down the center of it.
Down the hole?
Yeah, the rods are, it's actually a bobbin,
Mm-hmm.
and the rods are right through the center of this bobbin. Welding rod that you can get. And I think what you're looking at here is Lincoln Electric mild steel 1/16 by 36 R60. Okay, so we let our battery charge, and we had depleted this battery, and there we go. We have our battery back. So it's absolutely possible to recharge the battery with no current, because once again, I'm going to do this. I'm going to take the leads from the motor and connect it to the lights. The lights go out and there's no current there.
Lights go out here,
Mm-hmm.
and
There's no light here.
Mm-hmm.
right.
So therefore, there's no energy in current to charge that battery except for these small, minute spikes. So,
So that is the amazing mind of John Bedini, and oh, you weren't supposed to see that. I was working on Phase 2 guide. You might have gotten an inadvertent sneak peek on that. Anyways, John Bedini, he tried to tell us for decades, he tried to tell us this energy exists. It's so simple to use. And we have, here I'll show you, we have 2 Bedini SG circuits ready to go. Really the only thing holding me back from using it is I need to source the battery, and I don't have money for the battery right now. But as soon as we get the batteries, we can run the SG. Okay, and I'll show you a close-up of the diagram and everything in a moment. I showed it briefly earlier on live stream, but for those who are joining us, this is the Bedini SG solid-state circuit. I've got 2 of them. This one has a neat little speaker terminal input for easy access, but it's kind of janky, so we might end up using this one, which has the nice little heat sink on it. Ooh, yeah. Ooh, diddy. All right. So let me pull up the diagram for you guys. Actually, you know what? I think it's in Phase 2 guide. So let me... yep, here it is. Okay, so you will get a sneak peek into Phase 2 guide. Okay, so this is the diagram right here. Let me zoom in so you guys can see a little better. Oh, that's the wrong one. There we go. Okay, so this is the Bedini SG solid state circuit for our Rodin coil. And as you can see, it's just the basic solid-state circuit with the 2 coils. Instead of doing a traditional step-up coil, where he has basically a step-up transformer inside that coil. You have a smaller gauge wound together with a bigger gauge inside that coil that we just saw on the underneath the flywheel. But here, since we don't need an off gauge and the Rodin coil operates as a step-up transformer with the 1-to-1 ratio, we have modified the circuit. Mike Does and I have modified the circuit to include the Rodin coil's 2 channels. So here you see the positive of channel A and the negative of channel A, positive of channel B and the negative of channel B. And this is going to be really interesting. And here we have a close-up of that same circuit built to spec. And yes, we are feeding that energy. See, this is the negative of the battery. This is the positive of the battery. I believe, if I'm not mistaken, I believe this is the positive of the battery and this is the negative. And we're feeding that energy into the negative, forcing it into the negative. See, the diode forces it and can't go back. We have our power source here. That's our power battery, our 12-volt battery source. And you can see the positive goes up to the positive channel B. And this is our charged battery right here, by the way. Forgot to mention that.
negative, I believe, and this is the positive. And the negative of the channel B of the Rodin coil will go to this diode and to the collector of the transistor. Sorry, drew a blank there for a second. It's been a long day. We've had a long journey. And this is the base here. We trace the base back to the source. The base of the transistor is connected to, well, we connected it in a slightly different way with one resistor, so we just got rid of this one. But basically, it's connected to the one end of the resistor and one end of the capacitor. I believe this is the negative end, because this could be, used with a non-polarized capacitor, a ceramic one as well. But we are using a 1 unifarad 50 volt, I believe, capacitor, and I believe this is the negative. Let me double check. Negative is hooked up to, yes, I believe that's the negative, and the positive is hooked up to the other end of the coil. No. Take a look here. Yeah, it's hooked up to the negative coil. Okay, that's what it is. So it is the positive end of the capacitor that's hooked up to the resistor here, and then the jumper cable above it, and the same. I might actually have this hooked up wrong though. The negative of this capacitor, I don't think it's hooked up to the. Yeah, I definitely have this hooked up wrong. I'm just looking at this now, and I'm like, wow, I have this hooked up wrong. So maybe it's a good thing I'm going over this again. So it appears I have the positive end of the capacitor on the downside, on the bottom here, and that's connected to the base. No, that's connected. No, it's a negative. Okay, so it is a negative. But yeah, I might have that. I think I have that hooked up wrong. Hold on. So you got the negative going here, and it's junctioned off to both of. Okay, no, that's right. Never mind. This is correct. Never mind. This is all correct. I'm losing my mind. See, it's been a long day. So this is correct. So that is what I thought. This is the negative end of the capacitor connected to the base, and the end of the diode here. I think that's the cathode. It's the positive, I believe. So let's just double check this real quick. Base connected to the diode. Base here, jumper cable to the diode. Yes, to the diode, pushes that. Actually, the diode, is that in the right direction? Diode might be in the wrong direction. Yeah, that might be in the wrong direction. Let me double check that. So the diode looks like it might be in the wrong direction, because the base is supposed to be connected to this side, the side with the stripe. I believe that's the positive side. And yeah, so that's in the wrong direction. But other than that, I think the circuit is good. Let's see the emitter. The emitter goes to the other end of the diode, and the emitter on here, so we have the base for this transistor I'm using. We have it's the 13009. We have the base on the very right. We have the collector in the middle, and then the emitter on the very left. So the other end of this diode has to go into the emitter, which it does not. Hold on. Yeah, I think that's the wrong end. Let's see. Let's pull up the transistor. Image here real quick. All right. Yeah, so base collector emitter. Okay, so yes, I had the diode in the wrong direction and hooked up to the wrong part of the transistor. This is good that I'm going over this, because I would have hooked it up and it wouldn't have worked, and I would have been like, this piece of crap don't work. On to the next circuit. As Malcolm Bendel always says, spend 6 months preparing the metal or preparing your experiment. You know, then 1 hour trying to get your result. Don't spend 1 hour trying to build your circuit and then testing it for 6 months, because you're going to be disappointed when it doesn't work. Alright, so we're connecting that to the emitter. Oh no, wait, that was already connected. Hold on. So the base. Oh, it was in the right place. I see what I did. I'm crafty what I did. Okay, I see what I did there. Or no, maybe it was in the wrong place. But it was in the right direction. So, yeah. Okay, I see what I did there. Put that back in. And then we're going to go over to the mini lab again, and we're going to test those batteries. We might take a quick intermission before that, but test those batteries and get ready for Free Energy Fridays. Hopefully we get a email with that link soon. Yeah, Malcolm's PUM poster. Awesome. Yeah, awesome. That's so cool. I actually haven't grabbed one of those yet, so let me know how the quality is on that. Depending on the quality, I might have to adjust the image. So definitely let me know how that poster goes. But the PUM poster specifically is at cost. So all the money that's generated goes right to Streamlabs. I didn't want to make any money off of the PUM poster because that's Malcolm's thing. It's his, invention and idea, and I actually honestly just want to put it out there for the cheapest amount possible because I just want people to have it. So, yeah, so if you're not aware, the PUM poster is being sold at cost, not making any money off of that, and that's just because I want to help spread Malcolm's message, really. So, and unfortunately, Streamlabs is the easiest way to do that, and they're a little expensive, but we will be switching shops as soon as I can figure out how to transfer all of our designs. Hey, what's going on, Mike? How you doing? You'll be excited to know we're going to load up the PWM soon and attach it to a 9-volt battery. And specifically, I want to test how long it runs. Because we got it to run like 22 minutes last night. And I want to see what the baseline is, if we can get a baseline of something, how long it runs, maybe with the coil attached, but not within resonance. Maybe like a higher, we can't go lower than 1K, which was, I was planning on doing 60 hertz, but we'll do that eventually when we get a new PWM. That can go lower, but we're limited to 1K to I believe it's 99k kilohertz. So what we're gonna do is maybe just increase it so it just doesn't get any power at all, or very low amount of power really, and see how long we can get it to last. I don't know, maybe I don't know, what do you think? Should we go compare 1K to 3K? Because that's the range that it does best at. But there's a noticeable difference. Like it does pretty good at 1. Then at 2, it does well. And then at 3, it does really well. So maybe we'll run it at 1K versus 3K. Oh, awesome. We got a new Patreon supporter. Thanks, Sears. Thank you. Yeah, no, definitely look forward to the next episode that I'm releasing, which will be the first episode of The Benefactor's Guide to Free Energy Devices, which I can play the trailer during our next intermission, which is going to be in a few minutes. I'm going to mess with the PWM for a little bit, and then I'll take a quick intermission as we get ready for Free Energy Fridays. But yeah, appreciate all the support, guys. Really do. And I really hope that this works out. I'm really hoping, because I really have some exciting plans in store for Phase 3 that I can't go over right now. But if we can get this to work, Phase 3 is going to be amazing. And it truly is going to be the year of the coil. So, real quick, I wanted to show you guys this as well. So as you can see on the very right, I have a little LED indicator, and that is attached to the load. So if you have any kind of load, and I think that's where you put the high voltage lamps. I'm not sure on that. I have to check with Mike. But I put a little LED indicator on the load, which is connecting the collector and the emitter, simply because I just want to know that the circuit is working. Right? It's the easiest troubleshooting, step that you can implement in a circuit. It's putting a little indicator LED to make sure you're just getting power. If it's getting power, then that's at least the least of your worries. So, all right, let's get ready to go over to the mini lab. He said the LED will blow. Yeah, well, maybe I want to fry it and find out. It's probably best to attach a resistor to that, though. That's a good idea. Thank you for that. And I've got to disconnect this stereo amp mini board.
I only had one screw that fit, but as you can see, I kind of screwed it onto a block of wood so it's easier to handle. This is the pulse width modulator we will be using. At the bottom, on the right-hand side, which is the left-hand side when we're looking at it normally, we have the voltage plus, the power in, and the power negative. And then we have the output, which is the positive out and the negative out. So we will be using this to pulse our DC signal and power this with a 9-volt battery. And then we're going to be putting this output to the red and black wires on the coil, the input of the coil, and then the output, which is the green and the yellow, is going to be connected to the circuit here. We're going to also connect the oscilloscope. All right, and if I can find it, give me one moment. Oh, there it is. I'll show you what we're using to power the system using a 9-volt battery. I believe this came with my Arduino kit, but I can't confirm that. Anyways, it's just got a simple little positive and negative terminal output for your load. You can insert some jumper cables there and screw it down like we're going to do in a minute. And we're going to just plug this directly into the power, the V negative and V plus on our pulse width modulator. And we're going to power our pulse width modulator with a 9-volt battery. All right, just again, so you guys are aware, we are not using any other power other than a 9-volt battery for these next tests. Oh, my earplugs are disconnecting. They're running out of power. Let me put them on the cradle for a minute. 1 second. Ruin this climactic moment for us. God. All right. As you can see, brand new dual super heavy duty. I highly doubt that's super heavy duty. It's from the dollar store, basically. Got these for $1.25 at Dollar Tree, I believe. And we're going to test the voltage real quick before we hook it up. And keep in mind, I am going to have to freeze the frame real quick to tab out to my timer, because the timer is being used as the camera as well. So it might freeze when I switch to the timer and switch back. But fear not, it should only be a momentary freeze of the picture. All right, so we are going to set that up here. All right. 9.993 volts. You guys see that? 9.993. That's our reading from our battery. Again, as expected, it's brand new. You know, it should be reading like that. From now on, I'm going to test all my batteries from the dollar store. Maybe we can get more bang for our buck here. Because I know these batteries aren't known for their longevity. That adapter. Oh, my adapter fell somewhere. Give me a moment to look for it. Oh, there it is. All right. So we're going to plug it in. I know the audio is going to be a little low. Just bear with me. Tangle myself up here in this mic cord.
If I go down, just know I'm going down for science. Alright, plug this in. Look at what we have on here. Oh, look at what we have here. Alright, we're gonna time it. Alright, so we're running 24. I kicked it down. It was at 28 on the duty, the high duty. The low duty's at 1%. So we're at 24. I'm going to run it at 24 to 1 on the duty. I got the timer running. You guys can run your own timers too. It might help out. I'm going to hook up the oscilloscope in a second. So this is our pulse width modulator using a 9-volt battery, powering this 3 to 9 volt DC fan spinning pretty fast, and 3 white LEDs with a 2K ohm resistor. Now we're timing it to see how long this is going to take at 3 kilohertz. So looks like it's already slowing down, honestly. It really does. I'm going to grab the oscilloscope real quick. Yeah, it's already losing power. So when I was running it last night and it got 22 minutes, I'm not sure if it's the quality of the battery or it could be because I was using 2 kilohertz instead of 3. We'll test it in a second. I got a couple of batteries we can use here, but it looks like it's starting to slow down and the lights look like they're starting to get dim. Look at this. The signal is starting to get a little smaller. Yeah, you can already hear it. So the next test we do, when this runs all the way out, the next test we do is we're going to run it at 1 kilohertz and see how long it lasts. Okay, everybody? And I wasn't expecting this to run very long at all, connected to this big 8 ohm coil. Okay, it ran out. We are at 3 minutes, 5 seconds. So roughly 3 minutes. All right. So it only lasted 3 minutes, the fan. And the lights are still on, but we're going to count that as our time. Okay? Might as well switch it while it's on this dead battery while it lasts before I hook up the new one. Okay. So we're going to put it on 24 and at 1 kilohertz. Okay, yeah, you see the waveform? The lights are real dim now. The waveform's starting to go. Oh, upside down, sorry.
We're gonna connect our other battery. We'll test it real quick. Multimeter. So we're getting 10 volts with this. I mean, it's slightly higher. It just seems like it may be just slightly more closer to the edge of being filled or whatever. So this is the dead one. This is the new one. Don't want to get confused. Connect this one to our 9-volt adapter. We're going to plug it in. It's already set at everything. I'll time it. I can already hear it starting to die down. Yeah, it's definitely... I hate to say it, but I think it's the battery that I used. These are just... I guess this just proves, don't buy your batteries from the dollar store. Look at how low of a charge you get. They're like... I don't know what's wrong with these. Are they repurposed batteries that are sulfonated or... What the heck? Yeah, it's dead. Okay. 1 minute and 14 seconds. So at 1 kilohertz, we were getting 1 minute 14 seconds. And then the fan stopped at 24 high duty, 1 low. And that was at 1 kilohertz. Now at 3 kilohertz, we got about 3 times that at 3 minutes. Interesting, right? I mean, that in and of itself is very interesting because after all, we're trying to measure if this is having any effect in producing efficiency. So I think it's hard to say at this point, but this is a fun experiment. It's definitely more data points to add, but it doesn't really tell us anything indefinitely in and of itself. So there we go. Sorry, it keeps on disconnecting. It's still got a little bit of power going in there. Unfortunately, I don't think we're going to have luck powering our stereo amp receiver with these batteries tonight, simply because I see how low of amount of battery you actually get. Like, yeah, it's outputting 10 volts, but only for a few minutes in this system at least, whereas last night I used a battery. I'll show you the battery I used, a different brand, and it lasted 22 minutes. I think it was at 2 kilohertz. You can check my Patreon for the details. There's a video on there. But yeah, it lasted 22 minutes. So, and I'm not saying that my system was just that more efficient. What I'm saying is this battery is just that more crappy. Like, don't buy your batteries from the dollar store. Unfortunately, I only had $2 to spend, or $3 and some change, and I got these 2 packs. what I can show you real quick before we go to our intermission and prepare for League of Extraordinary Inventors. Well, I need to double check and make sure that's happening. I didn't get notice yet, but it usually happens on Friday. So I'm hoping that we get that email that it's going to happen. I hope Mike has a cool update for us on his experiments. He's working on some really cool things in energy production. If you're not familiar with his work, he does have a YouTube channel called Faraday Research. I highly suggest you subscribe. But for now, before we go to an intermission, I'm going to hook this PWM back up to the workbench power supply and just show you the waveform that's created with this pulsed DC signal that comes out of the PWM. And I'm going to show it to you at, 1 kilohertz through, like we'll go up to like maybe 10 or 20 kilohertz. We'll just go through it and look at the signal and see how distorted it gets outside of that range that it just rings like a bell. So I just got the email from Mike, so we are going to be preparing for Free Energy Fridays. Don't worry, you won't have to switch the stream as long as my stream doesn't crash or whatever. What I'm going to do is, after I do this quick experiment and show you the waveform, we'll go to a quick, we'll talk, catch up on chat, and then we'll go to intermission and prepare for Free Energy Fridays. And hopefully we have some cool updates from everybody from their research. I'm really excited to hear what Phil has to update us on as well. And, like everybody has some really interesting things that they're working on. If you're interested in these kinds of fringe science experiments and updates on fringe science, this is the place to be. There is no other place on YouTube right now that has a fringe think tank working on over unity energy, anti-gravitics, and all sorts of cool stuff. So if you would like to learn more about zero-point energy, for instance, I highly suggest you subscribe to this channel and stay tuned for Free Energy Fridays. You will learn a lot, as I always do. So right now we're putting 5.1 volts into the PWM and 0.29 amps. Excuse me. The PWM is currently set to 24% on the high duty and 1% on the low duty. We are currently at 1 kilohertz. Let's double check that. Yes, 1 kilohertz. All right, so we're going to change this, and I'm going to show you how this waveform changes. So we're just going to slowly increase it. 2 kilohertz. 3 kilohertz. 4 kilohertz. 5 kilohertz. Slow reduction in RPM in the fan. 6 kilohertz, same. 7, 8, 12. Oh, it jumped 1 or 2. 11, 12, 13, 14, 15. And we're just going up and up to 20, 25. Fan is almost stopped now. 30 kilohertz. And we'll zoom in here. Okay. 41 kilohertz. 52 kilohertz. Oh, look at this. It's forming back into an H. Hold on. 70 kilohertz. 80 kilohertz. Oh, 97. Let's go back down. Oh, look at that. 83. Let's zoom in a little bit. This looks like something. Let's increase the voltage. Oh, wow. Look at this. Look at that. Let's go down. This is at 83. Going down. Nope. We're shaping the wave now. Let's shape it. We're at 10 volts on the input. We're shaping the wave. I think we need to go higher. What do you think? Look, it's starting to shape on the bottom. It's starting to form that shape on the bottom. We're at 99. 10 volts, 0.12 amps. We're lighting these LEDs. I don't want to go too high on the voltage. Wow. I have to tell you guys, every time I run one of these tests, I'm always flabbergasted, astonished, and completely stumped. So what we just witnessed was I was going up the frequencies, and I have a Workbench power supply able to adjust the power input to what I want. Got to be careful not to fry my components now. So I was slowly increasing the voltage. I increased it to 10 volt input. Because, you know, as you know, if you've experimented with some of these resonance coils, as you go up the frequency you put into them, the amount of energy it takes, the amount of energy it takes goes down or goes up. So you'll put in, let's say, 1 kilohertz is what we were doing, and we were getting enough energy to spike the fan, make it go. As we go up that range and out of its resonance range, we're going into other ranges that are just going to completely distort the signal, even though we're getting, it appeared to be getting a decent amount of power. But it appears as we were getting close to 90, it was forming an H wave type wave with the transient spike, as you saw, and the hump on the top. And the bottom, as I was going up from 90 to 99, it showed the H wave was starting to form on the bottom, which tells me that was getting close to its harmonic resonance. And this is a harmonic range of that initial resonance range we saw. And my theory is we need to get to the third harmonic. So we need a lot higher frequency, in my theory now, for this PWM to work. I think. Now that I'm thinking about it, I don't know. We'll go back to the desk and see what you guys have to say. But I think this is really, really important news because it tells us what the limitations are of the PWM. Okay.
Hello everyone, welcome to Beneficence TV Live.
All right, let's see what everybody has to say before we go into our intermission and get ready for the League of Extraordinary Inventors. Very exciting indeed. So Mike has a lot to chime in here, and I have to read what he says because he has helped me get this far. His insights have been invaluable to my research and development of the Rodin Coil zero-point energy generator system. He suggests LED will blow neon to high voltage neon bulb. Okay, I'll put one of those. Needs over 120 volts to pass current. Regular incandescent, like 5 watt. You don't need Neo 2 so long as the charged battery is connected. It's safety part. Yeah, Sears chimed in and said, good thinking. Don't want to short out on a conductive surface or object. Duly noted. Thank you, gentlemen. Static voltmeter will last a few minutes. It'll also burn out from flyback unless you protect it. Okay. Mike says, I would think having a battery in parallel with your power supply, the battery will act like a protection from the flyback hitting the power. That could be, yeah. Yeah, we could do that. We could try that. 90% low, 10% high, he says, to try. We can do that later tonight when we load the system back up. Definitely try that. That's interesting. Let me write that down so I don't forget. Oh, crikey. What did I do with my pen? Try 90% low. 10% high on the duty cycle. All right. Much obliged, Mike and Sears and Nathan. I know he chimed in
little while ago. Appreciate all you guys' comments and your support. So, thus far, what I can conclude from our battery experiment is that the batteries we're using to test are insignificant. We need better batteries, and we need a better baseline. Otherwise, we can't really determine anything thus far with the battery other than the fact that the batteries from the dollar store are cheap as heck. And the batteries here, I was going to show you the other battery that I used, is a nice, decent battery. So when Sean is, hey Sean, Sean's here. Some impressive results. Thank you. If you're still Don says if you're still trying to invert your H-wave output, try swapping your leads on the output terminals. That's interesting. Yeah, but I don't want to just invert it. I want to reflect it. Like the H-wave still needs to be there on the top and the bottom. That's important, I guess, to replicate the exact waveform I was getting with the stereo amp receiver. But if Bedini says we don't care about the bottom, then maybe the top just is the only thing that matters, in which case we are getting somewhat of an H-wave, it appears, at around 90 to 99 kilohertz on the PWM, which is actually very significant, I think. Because we were getting, we weren't getting any power, and then it started, a little pocket of power, right? But you had to crank it up a little bit, the input. Yeah, I'll see you, Mike. I'll see you at the stream. StreamYard League. Hold on one second. So I try not to post the link to StreamYards publicly, Mike, because we did have a problem with somebody coming on there, and they got Bernie's channel banned. So I'm not going to be posting any StreamYards links on the chat. Just keep them to email only. Because what we do on the show for the podcast, for the Monday show, Nathan and I, we vet the person that wants to come on and present, make sure that they're serious and all that stuff. So. Hey, Cody, how you doing? Nice to see you here. Sean says, how do you measure over unity? Again, great time. I need a lab coat. So right now, the way I'm measuring for over unity, and I actually just had somebody comment about this earlier, and this is actually a very prominent question that he raises, but it doesn't discredit anything that I'm doing. It's just a side note. So the side note here, and the issue that this gentleman, or I think it was a gentleman, raised, is that you're not counting for the input power to the stereo amp receiver. It's getting requires anywhere from 40 to 60 watts depending on your, but that is true. When we're measuring for over unity in the system, we aren't including that initial input power for the stereo amp receiver. And the reason why is because I'm just trying to measure the raw output power of the stereo amp receiver compared to it hooked up to the coil. I want to see what the coil does to the signal. I want to see what it does to the energy in there. And regardless, and I've always said this, it's not going to be a perpetual motion machine, but it's just going to be very efficient. And the reason why we're not measuring the input power is because I just want to see the raw signal coming out and how it's coming out of the stereo amp alone, and then how that same signal is being shaped by the coil.
And what I see, and this is how I measure, I put a multimeter on the left channel and I put a multimeter on the right channel. Only the multimeter on the right channel is the output for the coil, right? So you have the right channel going to your reference circuit, the left channel going to your coil. Then the output for the coil goes to the circuit, the output circuit. And I put my multimeter right there junction between the coil's output wire and the power rail for the circuit. So it's right there for junctioning the power at its source. And what I've noticed is, obviously I've hooked up the multimeter to the other end of the speaker wire as well. And I've noticed that, both channels are getting the same amount of voltage and current out, right? They're getting this, technically the current is slightly different on the, I think it's slightly more on the coil side, because obviously the coil it has more resistance, it has 8 ohms of resistance in there. But when you measure the raw power and you look at how the energy is being shaped just with the coil, you compare the left circuit, which is the reference circuit, not hooked up to the coil, and the right, which is the coil and the output circuit. The left and the right, if your stereo amp is working as it should, and it should, you can test this, I have, should be outputting the same exact signal, same exact strength, same exact power, right? Because obviously if you're hooking up speakers to it, you don't want one left speaker being really loud and one right speaker being quiet. They're going to get the same amount of power, given that they have the same impedance, right? The same resistance or whatever. And what I've seen is empirically, the circuit on the reference side lights up and the fan spins nicely, while the circuit struggles on the output outside of the resonance range. So you say 60 hertz, what's coming out of the wall. It struggles on the output with the coil, obviously, because it's getting lost. But then I switch it to around 1 kilohertz, right? 100 hertz or 1000 hertz. And immediately you see a flip. And the reference circuit, the fan just goes from spinning fast to spinning really low. And the lights are really dim or even off. And the fan might be off depending on the power level. And I've had it where the fan is completely off and the lights are completely off. And then the output circuit's still going. It's still going strong. It's like going really fast and the lights are really bright. And then when I read that, it kind of confirms it. It's maintaining the current and it's doubling the voltage. It's pretty crazy. But we are going to go into an intermission, guys, and I will continue this conversation on the League of Extraordinary Inventors. You can see I'm losing my voice because I'm so excited about this research and the developments of it. I just can't stop talking about it. So I'm going to take a break, and you guys sit tight, and we will be back with the League of Extraordinary Inventors. Thanks, guys.
Imagine a world where time is no longer confined to the realm of science fiction. Pay attention to the video you are about to watch and see if you can notice the progress. That can speed up time in a small focused area, reducing the time it takes to heal wounds. Take a moment with me. Some of you might have even seen it, but don't know how to describe it. What you just witnessed was a micro-expression, and even though it only lasted
Sorry about that. I don't know why it always does that. Streamlabs is always screwing up. So I apologize, guys. I'm going to put something on for you guys to watch while we get ready. I'll probably play the trailer to my upcoming show, Benefactor's Guide to Free Energy Devices. Give me a moment, and I'll load it up and get ready for an awesome night of free energy.
stifled by greed and corruption. In a world where innovation is stifled by greed and corruption, there lies a hidden truth that could revolutionize our way of life.
Lenny, what are you doing? Are you seriously pitching a new show right now? I didn't authorize this. My God, only 5 minutes into your new position as co-host, and you're already adding to my tight schedule.
Yes, sir. I manage that schedule. But I did notice you have an entire 2 days available during your week.
Wait, you're not talking about Saturday and Sunday, are you?
Of course, sir. You have 2 whole days where you're free to work on new content.
Lenny, those are my days off.
It's okay, sir. I know you'll manage just fine. I have faith in you.
Do robots have faith?
I do. I have faith that you won't screw it up again.
You know what? It's fine. Go ahead. I'll just build my cold fusion Lego set some other time.
It's Pond certified.
But I'm not telling them about my idea for a thunderstorm toilet. I'm gonna keep that baby close to my chest.
You know, that just sounds wrong.
It's a good idea. A toilet capable of turning any toxic human waste into, well, it turns into petroleum jelly.
Why petroleum jelly, sir?
You know what? I'm not sure. I don't think it's calibrated correctly.
Enough is enough. The world is at a breaking point. Catastrophic climate change, biosphere collapse, and a global energy crisis have been met with apathy, denial, and despair. The phrase unidentified flying object is a deliberately obfuscating term. What it really is an alternative energy and propulsion device. This is the real reason for the secrecy. These technologies, if they were disclosed, would end fossil fuels, pollution, and poverty overnight, and usher in a new era of abundance, freedom, and peace. Instead, they have been kept secret for over 100 years.
The more powerful the agency, the more powerful the group, the more powerful the cartel, the more they will resort not only to legal means, but to extra legal means to suppress their competition.
I said pretty early on, the problem is suppression. It wasn't really how do I make a free energy machine. It's how do I not get suppressed? Because what's the point?
Microscopic ball lightnings that when they discharge are tapping into that 0-point energy field and creating the motive force.
Boom! That's why the concussion from the thunderclap is so huge. There's this huge amount of energy, and it's actually sourced from the vacuum energy. All the dots connected. This is what's happening, right? So we need to make the thunderclap engine.
Imagine a future where clean, sustainable energy is not just a dream, but a reality. Discover the countless untold stories of free energy devices and the relentless battle against those who seek to suppress them for their own gain.
Black shelving. So someone comes along, they offer you $20 million for your device, it's a corporation, they put it on a shelf. Boom.
This power is something I have given my life for you the people.
Uncover the shocking tactics used by energy industries to control the narrative and maintain their grip on power.
You don't interfere with the big, powerful people. You don't put them out of business. They still have those 50-year leases on the lines and on the power transformers.
Environmental Protection Agency is a bit of a dictatorial police agency.
A shadowy government with its own Air Force, its own Navy, its own fundraising mechanism, and the ability to pursue his own ideas of the national interest, free from all checks and balances, and free from the law itself.
This is real, usable power. It's stable. It is not transient. It is not noise. Behind the lamps, that little box is putting out all of that power, well over 500 watts, and yet it is receiving less than 1/3 of a milliwatt of input power. The rest of that power is coming out of the surging energy of the vacuum. And this little box that you see right here solid state, no moving parts, is the vacuum triode that's doing this very practical and historical work.
But indeed, it put out more energy than it took in.
He was shot at once with a silenced rifle from about 300 yards. It reads like the James Bond movie, but it's real.
There are men here that said they're FBI, and they got black vans, and they're taking all this equipment. What should I do?
It's called capture, where they try to rationalize away this problem and everything's fine.
From manipulation of patent authorities to infiltration of government agencies, the truth is stranger than fiction. But amidst the darkness, a glimmer of hope emerges in the form of renegade scientists and inventors who refuse to be silenced.
There is absolutely no question that T. Henry Morey had a system that produced about 50 kilowatts out of a 55-pound box.
In the shadows of capitalism's dark secrets, join us on a thrilling new show. Get ready to be inspired, enraged, and empowered as we delve into the benefactor's guide to free energy devices.
Only on Beneficence TV.
When it's really not medicine, it's nutrition. I mean, God damn, get the terminology right. You can't flag somebody for talking nutrition.
Same thing with veg.
In the depths of hidden files, trapped inside the secret circuits, unraveling through the miles, oh, truth was masked by coded curtains. You didn't know, we're shattering the silence, feel the power, revelations on the rise. The shadows lie emerges, breaking through the veils of dark. 0 points and gravities converge, yeah. Dying voices, revelation start. Ancient whispers call, they're begging us to open our eyes. We stand tall, defying all their lies. You didn't know, we're shattering the silence, feel the power, revelations on the rise.
Hello everyone, welcome to Beneficence TV Live.
Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Energy Friday, and it is September 27th, 2024, Friday night. Welcome to the show. We got Philip on. We have Old Man Bill's Nathan. We got Mike Does, and we have Lulu. And hopefully Ben will show up soon. I seen that he tried to log in earlier, but he got disconnected. But I know he's been doing a lot of shows. Oh, there's Ben.
Yeah.
All right, we got Ben.
What's up, Ben?
Hey, how you doing, guys?
Hey, Ben.
How's it going?
Pretty good.
Happy,
Back in the lab again today.
Yep. Happy Free Energy Friday.
Yes, happy Free Energy Fridays. I hope it's a good one.
Yeah.
Usually is.
It's always is.
That's right. I don't think we've had a bad Free Energy Friday other than having computer issues or getting knocked off. Or...
Yeah, like you see, I just got like disconnected, and it was showed me in the room. It didn't say disconnected, so it was a weird glitch. So I didn't even know until you said something, and I just refreshed the page.
Well, put it to you this way: I'm running the show off my freaking cell phone right now because my computer, my computer is being a complete ass.
But you need to install Linux, man.
Yeah.
I need you. Phil, I need your software. Send me. I'll give you my address.
Yeah, he needs a cleanup in there because he's been having problems for weeks.
Oh, it's unbelievable. Yeah, that's just one of my headaches. But thank God I got my phone running the show tonight. So we'll see what happens with that. I think actually it probably works better than my freaking laptop. So at this point, it's like, okay, I kind of throw my hands in the air and it's just the way it's going to be, right?
It's pretty awesome.
Yeah.
My mom, she's using Linux. I installed it for her, and I'm helping her remotely. So it's...
Yeah, I need your help. Please help me.
Yeah, I will. I mean,
It's reliable.
It's pretty easy. I just need the remote access, and I'll set it up. And then you can cut the remote access, and you're good to go.
Yeah, I think I have an external hard drive, and the hard drive that came with this computer is like horrible. It's too small. So it's like, yeah, it's the main hard drive on my laptop's too small. So if I try to add something to it, then my computer just kind of buggers off on me and doesn't cooperate. So.
Yeah.
What can I do, right?
But you have the external hard drive. You have an adapter and all that.
I got the external hard drive right here. I'll show you.
Yeah.
One of these guys, right?
Yeah, I don't know. That's not good to run off those things because the USB is slower. It could cause bugs in it.
But I use it mainly for backup. For
files. Yeah.
Like I download all my YouTube videos, back them up just in case YouTube decides to pull the plug on me for whatever reason.
But the problem with Windows, you're probably gonna get shadow banned for that. But the problem with Windows is over time it always slows down. Your operating system will always slow down after a year. I think that's intentional because they want you to buy a new computer and buy new operating system. So it's marketing stuff. That's why you don't want Windows. You just leave Windows for the government employees and people who play games and stuff like that. But if you install Linux, you can update your computer only once every 10 years.
Right. Yeah. Well, I just gotta make
right
do with what I have right now.
Well, Linux updates too, but you're just not going to have any failures like with Windows.
I have very little experience with Linux. I did dabble with it about 20 years ago when I was building voice over IP networks. It was mainly a Linux-based
Yeah,
software.
back then it was just too difficult. That's Red Hat and stuff.
No, but it's
Well-
pretty easy these days. Ubuntu 22 is pretty easy to install compared to before.
Right. It's way easier. Anybody can do it. It's like installing Windows now.
Yeah.
Yeah.
So worst case, I can support you remotely or something like that.
They drastically improved the GUI. It's way used.
Yeah, maybe.
You just gotta make sure you get
during the
Kali
next
or
week
Ubuntu
whatever,
that has a user interface.
we can,
You still got to use
go
the
over.
terminal though to sometimes to install certain things. There's thing called the terminal. It's like using the command prompt in Windows.
I use SteamOS, and that's a pretty user-friendly version of Linux. They have a lot of automated systems in SteamOS.
I heard.
Yeah,
about
but
that.
you try to use a mainstream Linux because you have more support, more
a game
people
platform,
working
isn't
on
it?
and it's easier to maintain if you have greater support. And it's Debian based, so Debian has been.
I'm pretty sure SteamOS is Debian as well.
Oh yeah.
They just
Yeah.
install it with a bunch of packages is all.
Oh, I got to show you guys something. I forgot. I totally forgot. Hold on. Bear with me here for a second. I wanted to show you guys this last week, and then I totally had a brain fart and forgot. So, because I'm working on my
Ben,
PowerShell
SteamOS is a game
technology.
platform.
Guess what I have?
It was built for it, but I use it for other stuff.
Yeah,
Haha.
I have it installed too. It's called.
is it?
Raspberry
What is
Pi.
Oh, nice.
Raspberry Pi.
Raspberry Pi. Oh
I've
yeah.
got a micro one, not a big one like that though.
Nice.
This is the full kit. It's the
thought it was
Raspberry
a phone.
Pi PI5 starter kit. And
Nice.
I also got an 8-channel relay module. So now I can control the timing circuit of my PowerCell technology.
Nice.
Nice.
Yeah. It's all brand
This whole
new.
time I thought the Raspberry Pi was a cell phone.
No, it's a full
No.
friggin' PC, man.
You can build anything with the Raspberry.
Like a Raspberry
Pi.
phone.
Oh yeah.
Yeah, it's
Like, this is
basically like a
really-
miniature motherboard with a bunch of components you can put
Yeah.
on. Like, sometimes it has an audio board and.
That's it.
Nice.
never
What are
looked
you
into
planning
it.
to build?
Well, I'm building the timer circuit for the PowerCell charger. So it's going to control the actual cells themselves.
Oh, okay.
Yeah.
Do you have
So,
multiple cells?
Yeah, well, this one's an 8-channel, so I could actually have 8 channels of control over the cells, and however I decide to configure them. So these are relays. I'll show you. They're actually, I think they're 10 amp. What is it? 250 volt AC at 10 amps or DC 30 volts at 10 amps. That's what they're capable. It's really cool. It came with a little screwdriver. Oops. Drop all the wiring. So there's all the relays on the board.
Yeah. Cool.
Yeah, there's 8 relays. And it came with the wiring, so that plugs right into the Raspberry Pi.
So now you got no choice but to learn Linux if you want to program your Raspberry Pi.
Yeah, yeah. I got to do a crash course in brain surgery again.
Yeah.
Again. But I usually do pick it up. I have a knack for it. Even when I got into building 3D printers back in 2012, I was building ripraps, and I had to basically, do all the bootstrap and get the motherboard program, get all the downloads online from Arduino for the controller for the 3D printers. I had to configure it all, boot it all up to the motherboard, then plug it into the printer, and then configure the printer parameters. And I was doing all this almost 15 years ago. So I had to learn it. I had nobody to teach me. I had to do this all on my own, right? And I did it. I was able to get a printer running. So I was building.
That's a
some pretty
testament
cool
to your
printers.
experience and skills.
Yeah, probably forgot most of it.
I had to use Linux Line in order for my printer.
When I was studying back in 1999, I was installing Linux, Red Hat, using a modem.
I remember the Red Hat.
Yeah, Red Hat,
Yeah, I
and
remember
you had
that.
to download the one package at a time. It was not like telling you
God.
which. You had to figure out which dependencies to download by yourself
Yeah.
because the
Well, back
RPM.
in 2005, 2006, I was building voice over IP systems using Trixbox. So I had a Dell server, and that's all Linux based, and I had to configure the Trixbox, and I actually had my own private network. So, and you could actually buy like little cell phones that work on a voice over IP. Like this going back years ago, right? And yeah, I got it working. As long as I had a Wi-Fi connection, I could make free phone calls on my network. So it didn't cost me anything.
The person who wrote Linux originally, I forget his name, but he wrote I'm sorry, what was that, Phil?
Linus Torvalds.
Yeah, I believe, if I'm not mistaken, he wrote Linux so it's like highly efficient, or you can program it to be highly efficient. Like you have ultimate control on like every single component.
Yeah. It's highly efficient for sure.
Mm-hmm.
Compared to Windows and Mac. Did you know that the Mac? It's pretty easy to make the Mac crash. All you have to do is watch IPTV, and it's gonna make the whole system crash overnight.
Yeah, that's right. That's funny.
It's gonna drain all the memory.
Oh, even Linux won't crash. It takes a lot to crash Linux, but if you don't have the hardware to support like a high resolution movie or something,
Things flying now.
Yeah.
Yeah, it's not. I mean, it handles multimedia, but it's not optimized for multimedia.
right? You need good enough video card for that, or otherwise it'll like skip and stuff.
My printer's just hauling ass now.
So now you can 3D print for the world. That's cool. That's cool.
Nice. Yeah, 600 millimeters a second. Thing flies like it's Travis is just insanely fast.
Injected epinephrine into his printer.
Every time I ask the guy to 3D print stuff for me, he always makes mistakes. Do you make mistakes often, or he 3D prints correctly right out the box every time?
Well, I don't get too many failures. The only reason why I had some failures lately is 3D printer filament kind of has like a shelf life. And I didn't print for about a year. So a lot of the printer filament that I had accumulated so much moisture and the filament got brittle and started breaking on me. So I'm going to have to order some new filament. And well, I'm using this one. This one's Hello 3D. They've always had a pretty darn solid printer filament. So this one's turning out pretty good. I'm pretty happy with this print so far.
Nice.
Yeah, it's fast. This thing just blows me away. I used to have a TiVo Tornado, and this thing just smokes it like in every way.
What are you making?
Making cases for my batteries.
Okay.
That's cool, man. You're all loaded now with the Raspberry Pi and your 3D printer.
Yeah.
Yeah.
Well, this one has, I think they call it Sapphire. It's a network, so I could actually install a webcam in this, and I can go on the road, log into my Sapphire account, and I can actually watch my printer on the road.
Nice.
Yeah. Yeah, it's all integrated in the motherboard in this printer, so I haven't really had a chance to dabble with that yet.
I wonder if anybody really uses that.
Oh yeah, they do.
The hardcore guys do, yeah.
Because they want to print something next, and they want to see when it's done, so they can set the next print or whatever right away.
Yeah, you could just hook up the webcam inside, and You can go on the road. You can actually control the printer from the road.
Oh wow, it has like command power. That's really cool.
Yeah, it's remote access.
It's too bad it can't remove the thing it just made and make another one automatically.
Yeah.
I guess you
That'd be
guys
cool.
already noticed that flaw.
Yeah.
Well,
damn it.
we haven't got that advanced yet.
It's not automated. It's automated, but you can only make one device, one thing at a time. You have to be there
Like,
to move it.
I'm pretty
Yeah, if you get a printer
confident with
jam,
this
you're screwed,
printer.
right?
Like, I could. Sorry, Ben. Go ahead.
I was just saying, if you get the printer jam,
That's the next
you have to
phase
be-
of the printers, the upgrade.
But that's a nice printer. What model is
Yeah.
that again?
Quiddy X Plus 3.
And I like
That's
the
the
green
screen.
color, by the way. I need to get.
Yeah,
something
I
like that for
printed.
my-
Yeah, it's a decent size. It's 12 by 12 build volume. Actually, sorry, 280 by 280
Huh.
millimeters. So it's like 11 and 3/4 inches. Now the 3D Max is slightly bigger than this. It's a full solid 12-inch build volume. But for
It's a
what
nice
I do,
size.
this is my Patreon's bought it for me.
That's awesome. No, that's good. You know, that means they're enthusiastic about your research and they want to see it develop. That's
Yeah.
freaking great.
Slip.
Almost slipped there.
That's okay. I don't mind. I slip too sometimes.
Yeah, it happens. I apologize, ladies and gentlemen. This is supposed to be a family-friendly show.
What happened?
Supposed to be.
I didn't get it. I
Supposed to
didn't
be.
catch it. Whatever happened, it totally went through me. I didn't get it. What happened there? What slipped? What are you talking about?
I almost said a word, a cuss word.
Oh. Well, what is it? What's the first letter?
The F word.
Oh.
Yeah, that's a good one.
I drop the F bomb quite frequently off camera, so just FYI.
Yeah, don't we all, huh?
So yeah, it's a little process to train yourself to.
You know,
to
it's like a flock of birds, you know.
Mike. Okay, sorry. Other
You can
Mike.
always find another word to use, you know. That's my point there.
Yeah.
Yeah, but when you're working, it's so fun. It gets out stress.
Mm-hmm.
It still gets out the stress, even though it's not the right spelling.
I think I only like curse words if I'm angry. But that's I'm angry. Like never it probably comes out.
I'm thinking to get one of those printers eventually.
Yeah, I gotta get one too. I need to print out a casing for mine. Now that we got the mini board working, it's gonna be important.
Can I talk about my failed experiments a little bit?
I wanted to hear about your experiments, Phil. I wanted to hear some updates.
Yeah, I did, but this week it kind of failed. But I'm just gonna talk about it because it's people might learn stuff. I'm just gonna share my screen. Present. Share screen.
Yeah, dude, I fail constantly. I always learn something from it. We failed
Yeah,
earlier, and I learned a lot from it.
Yeah.
I think
So
like fail forward, not backward.
Yeah. Fall forward.
So I made some calculations. This is the gravitomagnetic permeability that I found using my vortex experiment that I did 2 weeks ago. With that, I can calculate the number of kilogram per coulomb. This is the number of kilogram per coulomb, which is approximately 21,000 kilogram per coulomb. And if you calculate the linear charge density of an electric wire based on an electric field of 200 volts per meter, then you're gonna get a linear charge density of 4.4 times 10 to the minus 11 coulomb per meter. And with that, you can estimate, you can calculate the frequency of an electric field. You divide it by the speed of light divided by eta, which is the kilogram per coulomb constant that I just found. But the problem is, the big problem is I get 5 times 10 to the minus 10 hertz, which is extremely low frequency.
So wait, let me slow you down. You said you can calculate the frequency of an electric field with knowing the kilograms per coulomb.
Yeah, exactly. It's
as one of your variables is the kilograms per coulomb is one of your variables in your calculation to figure out the frequency of an electric field, and the other variable would be the EMF reading you get off the electric.
Yeah, field? The EMF reading is E. You divide it by the speed of light, but also with the constant, the kilogram per coulomb. And you're going to get the frequency
of the electric field that generated the magnetic field that you measured.
No, it's a pure electric field. So that's
but you had to measure E, right? What is that? Energy?
Yeah, I did actually measured it with.
So if energy is your variable, what does energy stand for? Is that the magnetic field? What is the energy?
The energy E stands for the electric field. This is an EMF meter.
Well, the field that the electric
trying to hypnotize me
is
right
a
now.
magnetic field.
Sorry?
Nothing. I was just saying you're trying to hypnotize me. That thing is cool.
Yeah.
That's your EMF meter?
I'm trying to hypnotize him.
He's trying to beam us up.
Exactly.
Yeah, that's cool. I want to get one of those.
What do you call that thing?
Yeah, you can measure the electric field.
Star Trek walkie-talkie.
Yeah, the magnetic field and the radio frequency.
The radio
That's not a tri-field meter.
The
it's
transponder.
So
you're measuring. What does that measure though? EMF or what is it?
Yeah, either a magnetic field, an electric field, or
it measures both. Huh?
Radio frequency.
Oh, nice.
It measures both the electric field and the magnetic field
separately.
Yes.
And what do you get? Different numbers on that?
Yeah. So if that's the magnetic field. I don't have a magnet. It's kind of a way. But this is the electric field right here. Huh. So if I move
is that a static electric field or is that a dynamic electric field, a moving electric field? Is it,
No,
you could be measuring the screen of your computer right now.
Yeah, but it's a LCD.
That's the static field. That's not the same thing. That's not the same energy that generated the magnetic field, is what I'm saying.
No, that's really the.
Anybody disagree with on? Go ahead, shoot. Because I'm telling you, you need a moving, not a moving, but you need amplitude to generate magnetic field. You can a steady magnetic field. You can generate a strong magnetic field in a pulse using very low amplitude, or what was it, amplitude, low current, low amplitude. But a lot of voltage, and you're still going to get a very decent magnetic pulse off that.
See, I have a power cord here, and if I put the electric field reader, the meter next to it, then you're going to measure quite a strong electric field.
What model is that? I want to buy one.
Yeah, it's like $40. It's called Tessman EMF meter.
That's the end of the cord. If you plug something into it and measure where the load is being created, it's a whole different ball game. You're going to get a much bigger reading.
Yeah.
And a much bigger magnetic field there at that point too.
That's cool though. That was really cool.
And that's the electric field. I'll show you for the magnetic field. One sec. Well, I gotta be careful with.
I mean, what I think understand is when you create a load, you're going to have at that point where the load is being transferred to the load itself from the source, you're going to have a lot of magnetic field going on.
That's a magnet right here. So it measures the magnetic field now.
Nice.
What are you measuring? The light, the flashlight?
He's got a magnet in his hand.
Oh, a magnet. It's a magnet.
Yeah, that's a magnet.
And measuring the gauge, magnetic field, right?
Yeah, the Tesla or the Gauss. There's two modes. And I can also measure the RF, the radio frequency signal of the Wi-Fi is pretty strong. If you measure the radio frequency of the Wi-Fi box, it emits a lot of radiation. So wherever your Wi-Fi box is in the house, you better be far away from it because it's pretty. There's a lot of radiation coming out of it. Even the cell phone. See 1 second here.
Yeah, that's because they turn up the amplitude because they don't want to have any drops on the signal. They can turn down the amplitude, get their tuning better, and they don't need all that power.
Even the cell phone, see? So, 1 sec.
Well, what I'm saying is that they got the tuning down so well already, with cell phones.
So that's my cell phone. And see, look at that's the radio frequency of the cell phone.
Right. I just think they turn the amplitude too high. I heard that on the towers, they turn the amplitude up too much on the transmitter.
So the cell phone emits a lot of radiation.
Like for them, it's a cost benefit for them to turn the power up because they don't pay a lot for that compared to what they make,
Yeah.
So they turn the power up on their transmitters so they don't get any complaints from nowhere. Or whatever, but at the same time, they can turn it down to the right level and the signal would be even better. But
actually,
it's a lot of work to tune all those transmitters and get the amplitude just right on all of them.
Yeah, look at that. I'm gonna turn the personal hotspot on.
They're going to one day develop an algorithm or something to run these transmitters remotely on their amplitude to adjust for the weather and all kinds of things like that. All this stuff is new, man. This, wireless stuff. I mean, Tesla came up with it 100 years ago. Now it's blowing up like everywhere.
That's the radio frequency of the hotspot of the cell phone. A lot of radiation coming out of it.
But Tesla was using lower frequencies. He wasn't using high frequencies. He was using FM for his boat.
Yeah, and I also bought a low frequency, like you were talking about, the low frequency radio that I bought last week. I wanted to measure the frequency of the electric field and the magnet, but it turns out I made mistakes in my calculations, and the frequency I'm expecting was way too low. So it's way too low. So I'll just
FM is already megahertz. That's high enough. You don't need to go into the gigahertz, but they do anyway.
Yeah, actually, here's the experiment. I'm gonna.
If they go into the terahertz, there'll be, those towers will be beaming out light rays because that's close enough to light.
So that's around 80 kilohertz. The line, the vertical line you see on the screen, is around 80
not popping up.
kilohertz. but now I'm hovering power cord next to the antenna, and you see the frequency spiking on the screen on the right. Every time I hover the power cord very close to the antenna. So I thought that I had the right frequency, but it turns out I don't. I didn't have the right frequency, so I made the wrong calculations, and but I wanted to solve the I wanted to solve the exact value for the gravitomagnetic permeability this way, but turns out the frequency is way too low. And I also have like RTL SDR adapter. That stuff here. Anyway,
Are you looking for a diamagnetic effect or something more concentrated, or both? Because in the center you could probably get a concentrated magnetic field, and then the outer perimeter you can get the diamagnetic effect.
But the diamagnetic, it's no. I just wanted to measure the
like
frequency.
the water. The water is like diamagnetic. It's lightly magnetized.
Yeah.
Stuff that's
No, I just
lightly-
want to measure the frequency of energy density field. That was my goal, but it turns out it's way too low. So yeah. So
Technically speaking, if water is diamagnetic, and you got water in the air, and if you have a device generating a field, I'll stop there.
Yeah.
And which test was this for? Was that for the water test with the 2 tubes we saw last time?
The MHD, right?
No, there was an independent test that was not related to the electrolysis or the MHD vortex. Just an independent test.
Oh, different thing. Okay.
Yeah. Because it's related to the same maths behind. I wanted to solve the gravitomagnetic permeability.
Right. You're
I
using
already
the
have an
MHD for your
idea.
gravity experiment.
Sorry?
Yeah, and that's where the MHD is. You're using that for the gravity experiment part of it.
Yeah. I'm using it, but I just wanted to try to solve it differently. But I failed, man. I failed this week, but
How did you fail? What in the calculation, or where was the failure here? I don't get it. Your math didn't come out the way you thought it should, or what?
My equipment is not sensitive enough
to get to the numbers the way that you needed.
Yeah, like 10 to the minus 8 hertz. It's way too low. I thought
That's
it was
not a
80
failure.
plus.
That's just that's the manufacturer failure there, if you ask me.
Yeah, but I learned a lot. I mean, I learned how to read these low frequency waves. I learned about RTL, SDR, all that
You're
stuff.
talking about a frequency that's like one pulse every 100 years or something. It sounds like very slow frequency.
Yeah, exactly. It's very slow. But apparently
That is strange. That's actually existing, like a pulse every 100 years, that kind of stuff happens,
Yeah.
In our time, Earth time, every 100 Earth years. And it happens not on Earth, somewhere else.
So technically we can
The
say that
relativity of that boggles the mind. Like how do you differentiate between like that long distance in time between compared to a short one? Like how
if you think about it, that low, it would go very far through the cosmos because it's I don't know how to explain it. It's like it's very low frequency. So you send out one shock wave and it goes and goes and goes. You time it right, you send out the next shock wave and it goes and it goes and it goes. It's because it's such a low frequency.
How do they know?
That's crazy.
Guys, I'm just going to scoot out for a quick smoke. I'll be right back.
Okie doke.
How do they know it's every 100 years? I mean, we haven't had the technology to detect.
I'm just guessing. I don't know that. I mean, he said it was one to the frequency you were calculating was 1 to the power minus something.
Minus something.
10 to the minus 8 hertz.
I don't know what that is, but that's a very, that's like one pulse every, I don't know. I'm just guessing like 5 years. I don't know. It's a very slow frequency. It's not 7.4, 7.5 hertz here on Earth is 7.5 pulses a second, not one pulse every 5 years. So you can kind of look at it like that. That's how slow of a frequency he's looking to.
Yeah, I mean, so technically you can say that the electric field and the magnetic field barely have a frequency or have none, but there's still
it sounds like hard to calculate something like that,
Yeah, but I still learned a lot. I was optimistic because I did use ChatGPT to have estimates initially, but ChatGPT led me into error. So, I thought ChatGPT would tell me that the linear charge density was 15,000 coulomb per meter, but it turns out it's 1 times 10 to the minus 9 coulomb per meter. So there's an order of magnitude difference of 14 digits here.
Yeah,
you definitely need a calculator to follow any of this stuff he's saying, but he's been following it himself on the calculator. So I'm telling you,
You
I had a similar error with ChatGPT and the calculations for the battery earlier.
Yeah, it's frustrating because you need to understand the error of ChatGPT and figure out where it is. So it's just faster to calculate it on your own, and and it was not even doing it the correct way as well. So you got all in math ChatGPT. It's even ChatGPT 4. Right now we can, they shared ChatGPT 4 for a limited period of time every day. And it was 4, and it led me into error. So it's good to do when you're confused on something. It's going to clarify things, but in mathematics and science, it's very annoying when it's doing mistakes like that.
Are you trying? Which mode are you in? Scientific, engineering?
There's no modes. It's just ChatGPT.
Oh, yeah. I meant with your calculator when you're doing those calculations.
Yeah.
Using engineering or scientific? Scientific will get you the more accurate reading than engineering will.
Yeah, you use Maximo like you saw at the beginning of my presentation. I really love WX Maximo. It's written by MIT, and you can do calculus and a whole bunch of high precision calculations and stuff. So it's pretty good. So what's up, Nathan? What have you been up to?
I'm just trying to hold on right now. It's just,
yeah,
it's all come flying at me real quick. It's, between doing the shows and then my granddaughter's over here all the time. So I have zero time for myself anymore. So, yeah.
Just start drinking and you're going to forget your stuff. No, I'm just kidding.
Yeah, no, thank you.
I'm just kidding.
I don't, yeah.
I don't want to be a bad influence, but just kidding here.
Yeah, no, I get it. But no, it's fun, man. I had a chance to go over some schematics and stuff that we're working on the workshop. So I put those out. People are asking for it. We're doing a stereo circuit, so I had to go back and look at everything and figure it out, put it together. You know what I mean? Stuff like that. I've been collecting stuff. I've been out running around. I got a stereo receiver, and I got the magnet. I built my Rodin coil. So I'm about ready to catch up to Ben real quick here on what he's doing over there. And
are you there, Ben?
Yeah, I don't know if he's there.
Fall
So,
Yeah, I'm
asleep
here.
again?
but yeah, I'm about to catch up real quick to him and get all the experiments that he did real quick. Just some of the circuits I don't have all the parts yet, but that's okay. I'll just make do with what I have. So, yeah, about to start running frequency in this thing, see what it does. So, I expect we're going to get some good numbers out of it and finally figure it out because I'm going to find the resonance frequency of it. And then I'm going to see exactly how to pull in the load so that we can get this thing to multiply better than it has been. So, should make everything easier, including spinning the magnet.
Yeah, because I'm stumped on the big one, the Fireball. Like, I've been messing with it, and I think I need to hand it off to a more experienced electrical engineer.
Well, I'm going to run that sucker on DC first, and then I'm going to get that sucker to resonate real quick. And then
Well, I was just gonna say there is a way to make it run really good on DC. I just, I haven't cracked it yet, but I'm sure, you'll be able to, or at least give us some insight.
It's all in the frequency and getting it right. Yeah, I'll be able to do that.
Mike said to adjust the duty cycle. I might do that later tonight and see what happens, but he said to adjust the duty cycle so it's 90 high and then 10 low. So
No. 90 low.
90
and 10
low
high.
and 10 high. Yeah, so I might do that at some point tonight just to see what happens. But yeah,
I'm just going to take the duty cycle on the little Amazon deal and go up and down on it. So it's real quick, no programming, no nothing. Just plug it in and play it.
yeah, yeah. You just have to
So much
what's
easier.
it called? Sweeping it. Yeah.
Yeah, no, thank you. Well, I'll sweep it with the radio frequency first, put a 20K resistor on it, and then we'll sweep it, and I'll find out what the resonance frequency is. And then once I find the resonance frequency, it should be fairly simple and exactly what goes into this thing. There's no guessing at that point.
Yeah, yeah. Once you have the resonant frequency, then you can learn to manipulate that signal.
Yeah. I'll be able to change which wires I want where in order to get what I want. So it'll be pretty nice.
Yeah, and
And
I got a board for you that worked out well for us. I don't know if you saw it tonight, but it's only like $23 on Amazon, but it works pretty well, and it's really small. So if you're looking to do like a more portable version of the stereo amp, it's a pretty good alternative.
Nice. Well, I went over Gerald's exact schematic, and I put out a video on it so everybody understands what he was doing.
Oh, the stereo amp?
Yeah, he's using the transistor as a as how do I want to say this? It basically will blow up the transistor before heat gets back to your amp, is what it's doing. So,
can you bring that up? Do you have a picture that you could bring up real quick, or you said it's on a live stream?
Let me see. I could probably share it real quick. Yeah.
Yeah, because I'd be interested in taking a look at that, because I probably have all the components or most of them to build that and test it out tonight at some point.
So let me share it real quick. You see it? Or Mike's got it.
Oh, there we go.
That's not it.
What are you looking for?
So the stereo amp circuit diagram, I'm going to take a look at it, see if I have...
There you go. That's what Gerald built.
Oh, I do have the 13009. I knew I ordered that for a specific reason. I probably heard Gerald say it.
Yeah?
Yeah. So I knew I had that transistor for a reason. So I have that
Yeah.
transistor.
So I basically just went over the flow of the actual circuit, and he's using the transistor in a different way. It's just to take the back EMF so that it can take it and blow it in that transistor before it gets back through the resistor to your stereo amp. So
that's yeah, you could do that.
This is the, yeah, this
Like
is
a
the
fuse.
protection circuit.
yeah, that's what it is. It's not so
So-
much of it's
You
not
just do
so
like
much.
a fuse.
There you go. That's exactly what he's doing. So the idea is to catch that back EMF spike and it'll blow before your amp does. So
You can get
yeah.
transistors for under 40 cents, 30 cents. Get them in bulk, you get them real cheap.
Yeah, but it's an easy way to do it instead of blowing stuff up. That's kind of the main goal here. And it's not to amplify the circuit or anything else. Your back EMF that's created because of where he puts the power in, will automatically amplify the circuit.
Is that a diode on the very left between the coil and the resistor?
Yeah, I drew the arrow so you see the X. It just says that it can't go back that way. It always has to flow around the other way.
Do you have a preference on which kind of diode I should be using there, or does it not really matter?
The transistor is 400 volts, and I believe it's a 15 to 30 amp. Okay,
How
but
much is that?
it's 150 Celsius on the temperature, so it's going to lower both those numbers. So you have to watch that. So
How much is that transistor, that 400 volt?
How much what?
How much would that transistor cost, the 400 volter?
I don't know. I didn't look it up. I was just trying to get the circuit out for people so they can look. I had to look at the specs and see, you know what I mean, how far it go. But it's like it's enough to handle a Bedini spike. So when you get the back EMF, it'll handle that.
Sounds like
and
a
then
MOSFET.
when it gets too much, it'll blow.
So yeah, I have everything to build this. I'm gonna build it tonight and see how it works because I need some kind of protection for that mini board, because you know it's a mini board. It's not gonna be like have all the protection that's built into the stereo amp. So this would be great. But again, to the diode though, is there any preference of like which diode?
Well,
I have a whole
about the
box of different
protection
diodes.
to the stereo, you need to get the NE-2 neon bulb and put that. That's 120 volts. It requires 120 volts for anything.
You know,
to go
I have
through.
a neon bulb that came with my Tesla coil somewhere. I just gotta find it.
I just know that, guys, it's a known circuit. Gerald used it. It worked. Okay. And
Yeah, I'm just wondering which kind of diode.
The
to
neon
grab.
bulb will do the
I'll-
same
I'll
thing
grab
that
a-
Gerald was using the transistor to do. Only thing is, it will act like an indicator. You'll see when it's.
well, I'm just saying, this is what he gave us. So that's what I put out there. I followed the flow chart, and this is what
He was
it is.
using it to protect his thing from the spike, huh?
Yep. So from that back EMF spike you get, he's
Well, I
using
can
it
tell right now
to
he's
protect
never
it.
replicated the Bedini, because if he had, he would have just used the NE-2 bulb.
He did. Okay, hold
He
on.
did.
Hold on. He did at a later time do the Bedini circuit. But
Oh,
this
so
is
he's
the one he
pretty good.
used before the Bedini circuit. So we're just following his timeline on what he gave us.
Wait a minute. Yeah,
Oh, he
you want
was
to use
using
that
the
bulb
SG.
for that.
He was using the solid state, right?
I don't know which one he used. He didn't present it yet. I'm only trying to work backwards so that I can bring everybody up to date, because Ian was really on Gerald about this. So I want to make sure I got it out for him.
Yeah. Okay.
But
I have a
it
diode.
explains why the collector's not used. Basically, when you look at it, he doesn't use the collector at all because he just wants a one-way diode, but he wants to be able to temperature control the circuit.
So I have a 10 amp diode, 1000 volt, the 10A10. Do you think that would work? I think that might be the one that I choose.
Yes.
Yeah.
Yeah, that would work.
Yeah, I just don't want to. I don't want to leak out or blow or whatever.
No,
Well, if you blow a diode, it's a couple dollars. You know what I mean?
Yeah, exactly. Not even that.
What's that thing on the
Good
right? Not in red, the black writing. The thing on the right. I see diode coiled transistor. What's the thing? Oh, the battery. Is that the battery source?
Yeah, there's no battery on this. It's just a stereo amp.
Oh, stereo.
Yeah. So there's no batteries according to it. There's no extra power going in this. This is simply the
Emitter.
power of the stereo amp.
Oh, you put the transistor in line on the negative.
Yeah, look at those big boys.
Yeah. So anyway, that was it. Just kind of what I was working on. I had time today to put it together so that we can get it out there. That was it. It was kind of, I was spent all day watching my granddaughter, man, and running around after baby is tiring when you get old. I can tell you that right now. She moves way too fast.
Yeah, and they don't stop. They're like the Energizer
No.
Bunny.
Jeez.
Never run out of
Never
energy.
stops.
You want to see over unity?
The thing about the neon bulb is that nothing will go through it unless it has 120 volts or more with it of voltage. So as soon as the flyback, tries to go to your stereo, it's going to be over that voltage, and it will go through the neon instead of the stereo. And the neon will light up and you'll see it, and you'll be, oh Jesus, what am I doing
but
here?
you're talking about
I'm running
much more.
flyback back into my stereo. I better figure this out.
Yeah, but you're making a more complicated circuit than what it was.
It's
to
just a
do
light
that.
bulb. You put it across the two terminals, and it protects those two terminals from anything high
But the
voltage.
light bulb's also a diode, right?
No, it's a
That was not?
NE-2 high voltage neon.
Okay.
It's what the Bedini uses in his circuit for that, to protect the transistor from getting blown out by the flyback.
But the point of the circuit was to blow out the transistor before your stereo.
Yeah, well, this bulb doesn't blow out. It just keeps going, lighting up and protecting the transistor, so you don't have to keep changing it.
Okay.
It's a little bit more. And it's only, you get like 10 of them for $5, and they're not easy to burn them out.
So it has like a minimum for it to work, but the much higher max of
The minimum voltage it requires to pass any current through it is 120 volts,
in the max.
1,000 volts.
Oh, okay. All right.
It's just anything over 120, and it will allow current through it and create some kind of light. Very interesting light it creates on a new bulb. It looks like lightning, but after it burns a little bit, I don't know what gas is in there, but and then it turns like a yellow orange.
Here's my print that I just finished.
Nice.
It turned out great. I'm doing the second half of it now. That's like an hour and 50 minutes. So, yep. So far, so good.
It's used to protect the transistor. It's just a 2-terminal filament bulb, 2 terminals across the emitter and the collector. And if you disconnect the charge battery, that light will go off because in the Bedini circuit, the charge battery is there to funnel the flyback into the charge battery. So as soon as you disconnect the charge battery, the flyback is going to be hitting the transistor, and the light will go off if it's connected across the transistor.
Now, yeah, Gerald says that's exactly what a circuit was designed to do with what I was saying it did.
Yeah,
like
there's
that
many ways to
green,
protect your circuit with a fuse type device, but Bedini chose the NE-2 bulb probably because he didn't have to keep replacing it every time it burned out. It kept running and kept protecting the. I don't think it's anything particular about the bulb other than that, that it doesn't burn out. It's not easy to burn out that bulb.
That's because it's a load. He's putting a load on the system, and we're not trying to use that. We're just trying to bounce it.
No, this bulb doesn't have much of a load to it. It's got a very high resistance and a very small light bulb. I don't see it's not very bright either. So it's probably can handle a 1 amp before you burn the bulb. Maybe.
Look at Gerald. Oh, always something.
I don't think I've ever burned one. I got a bunch of them. I just, when you take a circuit apart and the leads get too short on the bulb and it's just hard to resolder it, so you just. But I've bought a 50-pack for $10. It went through half of that already. I still got every one of those neons in different boxes and mixed in parts. And they still work, I'm sure of it. They're not easy to burn them out. I don't know why. Because they don't take a load, really. They take the height, they take the voltage.
Yeah.
I don't know how to explain that, but they don't really take much current. But you could throw all the current you want at it. It's not going to take it because it's a very thin gauge coil, and it's not demanding any current. So
yeah, it might not work for this then because the whole circuit's designed for it to over amplify and blow up. That's what the circuit's designed for.
That's the flyback blowing stuff up. It's not a high amperage, the flyback, but it's a high voltage, and it will destroy microcircuitry anywhere in the vicinity. And
Remember
if
the
it's
last high
connected to the
voltage
circuit,
I
you
put
have
through one of these things, man, it started shooting sparks out like 2 inches long. It was great.
Yeah. You gotta keep your
use the
system analog.
variac and just crank it up, and it just boom, and it right at you, and you're like, yeah. You wanted to get out and videotape it, but you knew responsibly you had to stop and put it out. But I should have left it going. I would have loved to capture that. So.
Yeah, analog systems they're very durable.
Oh yeah.
When you start putting switches on things, that's the first thing that's going to go is the switch or the fuse or whatever. Fuse is the switch.
So, yeah, when you're I was filming this one time, and I was, because you're looking at it through the screen, you're not actually looking at it with your eyes straight up. So like I noticed something was smoking, and I didn't notice it right away. I'm like, is that something smoking? And then it delayed my reaction.
Well, hey Ben, it should also tell you what blew up in your amp. When you look at it, you know to look on the negative side of it and see what's behind it. I bet you're going to find a couple resistors and a diode dead.
Yeah, you're looking at it and you're going, oh no, oh no.
Well, if the flyback hit it, you're not going to really see smoke. But if this is,
well, he's not working with a flyback. He's working on that coil, and that coil's back EMF. It's like total pressure. It's just
maybe the coil drawing
Yeah,
too
it
much
gets
current,
insane.
and that'll burn
It
out
gets
something.
insane.
Well, what'd you do? Throw the gain all the way up on that thing?
Yeah, and you know what?
That's what's
It
blowing stuff out.
blows.
He keeps turning it up.
Well, the energy generation tests are fine, but specifically when I start messing with the neodymium sphere, because the extra energy I think that's created by it spinning is also adding to the back EMF, and I think it's just too much for it.
Because you're making a motor and a generator at once, and you're not pulling a heavy enough load to pull it out.
Exactly, it's not connected to anything really, nothing significant at least. No, you're absolutely right. I had the same thought.
Yeah, it'll be fun.
Yeah, no, these coils are fun to experiment with. I'm sure you're gonna have lots of fun with yours and show us some really cool stuff. I'm excited.
Yeah, I had to go get some more tube TVs too. I had to go raid some people to get them so I can get some more flybacks, because I don't like the new ones that they put out. They're too stiff. They don't. They're not been broken in enough.
You're telling me the new TVs have flyback?
No. I mean, like when you buy them from Amazon, the flybacks, they're not used enough.
Oh.
So they don't
TVs
break
got
down
that.
any bit. They're too powerful. I like the ones that have been used a bit, so they're kind of old. Then you get the
Be able to
better
find those new
voltage.
TVs. Just the old
They're just easier to manipulate. Let's just put it that way. So I bought two that were new, and oh man, it was the worst experience. I won't ever buy that kind again.
Old man builds, old man volts.
Yeah. Well,
Maybe the new
they,
ones have
they
it.
couldn't handle it, is what the problem was, and it starts sparking over the bottom. All I get is fires. So
That's interesting, because that's something I would never come to, like, I would never draw that conclusion. That's not something that I would have thought about. Like, that's the reason why, it's too powerful. It needs to wear a little bit.
yeah, well,
it's interesting.
Basically, it needs to build up some carbon in there a little bit, and then we'll be all right.
Yeah.
Get a little
That's
resistance,
cool.
and then I'm about where I want to be. So
No, that's interesting. That's awesome. I just, it's the last thing that I would have thought of.
well, when you're trying to pull straight charge out of one of these things, man, it's the most important thing in the world. You don't want those amps in there. You want them out. You want to create the dielectric between the two power lines. So you're looking to get as many amps out as possible so that you can get that field. And that field, man, once you get that, that's what you want. So
That field of just pure potential, like you said.
but yeah, well, it's the dielectric field that they were talking about. So it was Steinmetz and how he built the power lines and stuff like that. And that's exactly what I need, because I need pressure. And that's the pressure I'm going to get with it. So I need some good flybacks, because the last ones I had, it melted from the inside out.
Wow.
So, well, you start frying things with them, things happen.
Are the fly one size or different sizes?
They're different. Every one of them. Yeah. The ones that go in certain TVs are built for that TV. So you'll notice as soon as you open it up and you see a circuit board and you got a 200 volt, capacitor sitting there. And then when you get to the monitors for TVs, the old school ones, the monitors, the big ones, they were 400 volts. So your actual flybacks can run differently. So you get one massive dose on those other ones. If you could have connected to the monitor directly, you get a massive, it'll stop and then boom, it'll hit, right? Where the regular TV, you put them close and they give you that nice, you know what I mean, voltage in the purple and stuff. You pull them apart. Now you got a big charge in the center. And now you can put something in there to move it one direction or the other. So.
Those things are not in the flat screen TVs, the newer TVs.
No. They don't need them.
I think maybe they might have them. I don't know.
No, they don't. I tell you, they don't. I have some that I opened up just to find out was them, and they weren't in there.
Because I have a couple.
Oh, you did? Okay.
If you guys have access to the old tube TV, what you do is you set it up so you get basically like the white screen with the fuzz.
Mm-hmm.
Take a magnet, put it right up to the screen of the TV screen, and you'll see the lines of force of a magnet show up on the screen.
I've done that as a kid. I messed up so many TVs.
Yeah, it will eventually screw up the tube, but if you have access to old tube TVs, you can put magnets on there and you could actually see the lines of force going around the magnet. It's really awesome.
That's all it takes to just turn it on and then take the magnet to it?
Yep.
Oh, yep. Well. Give me just a few minutes. We'll see if it works.
Yeah, you're going to ruin that.
I'm going to do it right now.
It'll probably fry it. But
yeah.
What fry my flyback?
Probably not the flyback, but it could ruin the tube.
I don't give
a if you
about the tube.
Like if you hold it there too long, it probably will do damage.
Well,
but
let's give it a few seconds and try it. I always like blowing something up. Give me a minute. Let me set it up.
All right. Yeah.
I did not know Nathan had a daughter. I didn't.
You're breaking up there. Say it again.
I said I didn't know Nathan had a grandchild.
You're choppy.
You're all choppy. Say it again.
You're walking around. That's what it is. Oh no, you're not. Yeah, there you. I don't know. The signal's choppy.
Can you hear me?
There you go.
Yeah, that's better.
Yeah, I was saying I didn't know that Nathan had a daughter. I didn't think,
It came through pretty good there. What's he trying to blow up now?
The TV.
Yeah, he's going to put a magnet up to the old style tube. It will show the lines of force when you turn it on and you put it up to like the white screen, like where it's fuzzy, or even a dark screen. It'll show the lines of force of the magnet,
the
magnetic field. And know who used to do this? Floyd Sweet. He used to do that to tune his magnets for his vacuum triode.
Or wasn't he trying to detune his magnets a little bit?
Well, reprogram them or something like that.
I think he was trying to create a weak spot on the magnet.
Well, he was tuning the magnets. He was basically killing the magnet and then reprogramming it the way he wants.
Okay, here we go.
Ooh.
All right, hold on. Let me put you full screen here. Hold on. Let's go solo.
We're gonna watch a family video soon.
So we got a neodymium magnet.
Yeah, don't do it for long. You seeing anything? Try changing the station.
Oh, hold on. I'm seeing a little color. Hold on. So what do you want me to change it to?
Try that. Try
Yeah, the
try
white.
this-
The white fuzz.
Yeah, the white. Try the white fuzz. Okay,
I
put it
think
up.
it's to
You
be
can
a
see the
black.
color.
There we go. Nice.
Green.
Yeah. There's the lines of force of the magnet right there.
Yeah, you can see the color change, huh?
Yeah.
Go to a channel that's black screen.
Try black. Try a different station. Darker the better, maybe.
I can see it. You
Can
can
you
see
see
it
it?
following it. Yeah.
Yeah. So there you go. There's the line. Do you have a bar magnet? Try a bar magnet.
Well, Neos have a very short field, but they're strong field. A regular magnet. Would
Look at. Try to look at the lines of force going around the bar magnet.
Yeah, you should be able to tell.
Oh,
the
hold on, hold
polarity
on.
if
Look
it's
at
clear
it.
enough.
Look at it when I turn it. You can see it.
Yeah.
Yeah. Yeah.
Yep.
There you go. Okay, children, don't blow up your grandma's TV.
That's so cool. Thanks, Mike.
Nathan
Yeah,
told
there you
us to
go.
fry it and find out.
That's
what
it.
I want to do.
I taught everybody to destroy your tube TV.
No. But if I get an old one, I might do this experiment. This is cool.
Hold on.
Very cool.
Yeah, we'll just amplify the magnet. There we go. I put more
Yeah.
magnetic force on it.
Nice. Hey, you know
Cool.
what we could do, Nathan? We could use this to see how far the rodent coil's magnetic field extends.
Yeah, well, this TV is not going to last that long.
Oh, not maybe not. No,
Yeah.
not this one.
Yeah, don't do it for a long time. I don't want you to blow it up.
Oh, man, that's
But
fun.
you like that?
Very cool.
So Floyd Sweet was doing that after he retuned his magnets. He would put them up to the TV screen and see how he changed the force of the waveform, right?
Yeah,
So you
want
can pulse a
Mike?
magnet just by putting it up there? That's crazy. I never heard of that. That's awesome. I gotta try that.
Yeah. Yeah, very cool stuff.
Who did we lose?
Nathan. Yeah, Nathan dropped out. He'll be back. Hopefully. I mean, I dropped out earlier.
Maybe his magnet hit the computer.
Oh,
Yeah,
I hope
exactly.
not.
Oh no!
He demagnetized his computer, his hard drive.
No, there he is. Okay. You scared us, Nathan.
You thought you fried your computer with a magnet.
No. This thing's taking a lot more abuse than that.
He's got that thing in a Faraday cage by now.
Oh, this thing, it tells you when it's upset because it keeps dinging all the time when I start doing experiments. You always hear it in the background. I'm like, okay, I get it.
Yeah, so like what I was saying before, Floyd Sweet was doing that. He would bake his magnets, so when you heat up a magnet, it kills the field. Then he put it in the column tube with the coil, drop the magnet inside, and remagnetize the magnet, the ferrite magnet. Then he took the magnet and put it on the TV screen to see how he changed the field. Now, what he was looking for is not just the waveform, but it was now in motion. It was actually moving that waveform.
Oh,
So
nice.
basically, right. So because of the ferrite magnet, he reprogrammed it to oscillate.
There you
When he
go.
put it on the TV, you could see the magnet doing this.
Yeah.
Oscillate.
So it's
And
like
then he put it in the system and ran it.
That's cool. All right.
Yeah. He was doing that back in the early 1980s with John Bedini.
Nice.
He was,
He had to demagnetize it first, though?
Yeah, you heated up the magnet. When you heat up a magnet, it loses its magnetism, right? That's
right.
pretty much a well-known fact. So after he did that, he dropped it in that cylinder. Basically, it's a big coil of wire, and started magnetizing the ferrite magnet from 0 to whatever he wanted.
Nice.
Right.
Yep. Yeah, that's why high voltage and magnets don't work well.
Yeah.
So.
The heat demagnetizes them.
Yep.
From the high.
Yeah. Any magnet, if you heat it up, it destroys the field.
Yeah, I knew that. Yeah.
But if you heat it up and cool it down again, is it going back to normal?
No, it loses. No, you have to remagnetize it after that point.
Oh, yeah.
I saw this called a magnetometer. It's like a machine that you put any weak magnet, and it turns into one of the most powerful things. Like it just yeah. Magnetometer. Yeah.
Yep.
It's a cool machine. I mean, I would want one. You can make pretty much.
Nathan, I'm surprised your attitude TV kicking around.
I told you I need some flybacks. I need. That's where I get them. I go around, see who's got them. You know what I mean? To yard sales, stuff like that. You got it, man. I'm on it.
$5.
Yeah,
Pick them up for like $5.
About $20 sometimes. Yeah, sometimes 0. Sometimes take all of them. You know what I mean? And I'll pick up stereo amps the same way. You know what I mean? Anything that I need, I love yard sale shopping for this stuff because they just want it gone. And I always need circuits. Yeah.
One
my
man
wife's
rub another treasure.
Oh, by the way, I registered on Amazon Prime, so I get my pieces within 24 hours. It's pretty cool. Because I had there was an electronics store, by the way, Mike, in Montreal, but it's pretty far away.
yeah.
So I got tired of walking around, so I just registered to Amazon Prime,
right?
And you get it pretty quickly. So just by the way, if you need stuff quickly, then it's suggested for you.
Yeah. Well, I got that surplus that's not too far from me. Plus, I got Sale Electronics and A1 surplus. So I'm lucky that I live in a pretty good area where I have access to this stuff if I need to.
Yeah.
And last resort, it's AliExpress or Amazon.
Where did you get your Raspberry Pi board from?
Oh, this one was my partner that I'm working on the Cell project. He got it on Amazon.
Oh, yeah.
So,
there you go.
Yeah, it's like I think it's $329 for the newest one that I have. It is. I'll show everybody again. It is the
320.
Raspberry. Yeah, it's Raspberry Pi 5 starter kit. So
You're
it's
saying that the Adreno can't do what this thing does?
Well, this is just a different kind of Arduino. This one's Raspberry Pi. They kind of do the same things, but I think the Pi has more features. Like, I know the Arduino, you can't really hook up a monitor to it, where this thing has like a S-video port, so you can plug in any S-video monitor into it.
Yeah, the Arduino isn't as versatile, and the Arduino is only limited to 5-volt output as well.
Right, where this thing's got like huge options on it. Like it's totally so many things.
What kind of output voltage can you make on there?
It's more about processing power and what you need like that.
Yeah, it's all the triggering. It's got all the dip pins, so you can attach devices to it, right?
So you can trigger relays that require 12 volts.
Yeah. Well, I got the 8-channel relay.
You can't do that with you can't do that with an Arduino.
No. So that's why I got this. So now
you
I can
can, but
make
you have to
some
make a
pretty-
transformer and step up your 5 volts in line.
No, it has enough power for triggering.
No, I mean, so I'm saying on a regular relay, it requires 12 volts to trigger the relay, like a car relay. But if you have an
No,
Arduino that only puts out 5 volts, you're
No,
not
it's
going
a
to be able to
trigger.
trigger it.
It's mainly used as a triggering, right?
Right. Right. So you can trigger a bunch of transistors into.
Sure. Yeah, you can do many things with it. Yep. It's like a triggering interface, right? So, yeah. So I got to learn how to program that. That's going to be a crash course of brain surgery.
Just buy Raspberry Pi for Dummies or something like that, and you'll be good.
Yeah.
The book.
Yeah.
I would have given up on the Arduino if I didn't find the code I needed. It's just a pain in the butt, you know.
Well, yeah, there's a pretty big forum on this, so I'm pretty sure I can find all the code I need to run my my triggering interface. So I can, timer circuit and delay timing.
Yeah. If you don't know, if you can't find the code you need, you got to start from scratch and learn how to write it.
Well, the thing is, Raspberry Pi's been around for quite a few years now, so it's got a pretty big database. So I'm pretty sure I can find what I'm looking for.
Well, what I found code that I was able to alter in it to do what I wanted it to do.
Sure, yeah, most of them are, it gives you the basic framework of what you want, and then you can dial in the parameters that you want, right?
I think the Arduino only does five triggers, 5 signal outputs.
Yeah.
1 negative, 5 positives.
I like it. It comes with all the dip wires, so you can just plug and play. Basically, I can hook this up to my TV because it's got an S-video port. So, not S-video, but the other wire, what do they call it? The S-video or whatever port.
Plugging your TV into it?
Yep.
A composite?
Yeah, it has
Coaxial?
the plug-in. No, it's got the S-video. Yep, it's got the S-video port on it, so I can just plug it right on my TV.
So that you can read it and work with it.
Yeah, it's basically just a miniature PC. That's all it is.
Right.
It works the same way, right? But the difference with this is you can plug into this board, right?
Yeah, get it on the screen so you can see what you're doing.
Of course, yeah. Or you can buy one of those little 3-inch screens. You can buy one of those, plug it in, and then whatever device you have it, mount that monitor into the device so you can do all your corrections or adjustments right there on your device that you just built. And those and the other thing too is you can buy a touch screen. This thing will work with a touch screen. So you can make your own touch screen interface.
Well, you said you had like 15 outputs on there.
That's relays. Yeah. So if I'm doing trigger relays,
those are 5-volt outputs.
Yeah, it's a very small trigger. It's not very big, but it can handle up to 10 amps. At specs on its load voltage.
So this
right?
is just to run like industrial equipment and stuff.
Yeah, just listen to operation voltage is 5 volts. Okay, operating current is only 480 milliamps, so it doesn't take much power to run it. And then the load voltage, you can run AC 250 volts at 10 amps or DC 30 volts at 10 amps.
That's still a lot of current.
Yeah, for a little thing like this, yeah. It's excellent. It's really,
I don't know if I
really
would
good.
want to push that much current through it, being almost $400.
Well, no, it's just this board. This board will get affected. If you blow this up, it won't affect your Raspberry Pi. So, and these boards here, they only cost like $20.
Oh,
So it's, yeah, these things are
that's
cheap.
the relay board or something.
This is the relay board, HN.
So that's what handles the amperage. Okay.
This is the
Yeah,
miniature
that's worth
version
that's
of the
worth
Raspberry
experimenting with. Then yeah, go ahead and blow.
Yeah,
one
see,
up.
Ben's got it.
$20. You know.
This is the tiny one, and I got the battery attachment as well. But this is a little bit more inexpensive
Burn out your relay, though.
if you don't need as much processing power. And it's really small, really small.
Yeah,
Pretty
but
cool stuff.
it's perfect. Yeah.
Yeah, it's got a little slot for your SD card and everything for your memory.
Yep.
It's all in one
Yep.
thing. It's really cool.
How do you call that?
I don't know exactly what it's called, but it's the mini version of the Raspberry Pi.
Yeah.
Yeah.
Yeah, they come in different sizes.
And
You can see it
I'm
has
just
two
wondering.
micro USB, and then HDMI. I have a micro HDMI adapter
Yeah.
here.
Well,
Yeah,
what
this one has
processor are they
HDMI.
using? What processor are they using?
Good question.
EEPROM. It's
Yeah.
an EEPROM, right?
This is okay. The chip is 3IC77 D9WHV, and yeah, that's the processor. Whatever that means, I have no idea. It's a fairly decent motherboard. Like I've heard nothing but good things about Raspberry Pi.
So with your Raspberry, you should be able to flip two relays.
Oh, okay. Here we go. Okay, here's the processor. The processor is a quad-core Cortex A7664.
A quad-core what?
Quad-core Corex, CORTEX A7664. It's a quad-core, 4-core.
Sorry, I just had to slip in an Apple coil cameo.
The Raspberries are quad core. That's a pretty hardcore
Talking about
processing.
Yeah,
fruit
it is.
beer.
It is.
Yeah, no, it's got some pretty good processing power behind the full size Raspberry Pi. The mini one doesn't have a lot of processing power. Like if you don't require a lot, it's a good choice.
And how much is it?
I believe this one was like $300. The starter kit, it's like $300.
$300.
Yeah.
Dude, but for that price, you can buy a NVIDIA Jensen.
Well, you're getting a small package, right? You're getting a really small package, and
Yeah, size
you know
is a
it's
concern,
got
too.
all. He has all the pin connectors, so you can control other devices. This is like a triggering device for those devices.
I'll be honest, I haven't figured out what we're gonna use this Pi for, but it definitely is gonna be
I can give
useful
you an
for something.
application. I have
Yeah,
a nice
no, I'm
application.
open. I'm open.
Mike, see if you can get your Pi to switch two poles on two sources.
Yeah. Yep. Probably could. This could even run on a battery. UART connectors.
You got 15 relays on there. You have more than enough to do that.
Well, I got it. I have an 8.
You only need 4 relays to switch two poles on two sources.
Yeah.
But are these relays
yeah.
individual bus lines?
Yes. Yes.
Oh man, that's
They're individual. Yeah. I knew you were the first one.
That is something. I might end up doing the Raspberry. I didn't know it was that.
No, it's
that capable.
good. I'll show you again.
Yeah, the Arduino is very limited, especially when you're working with higher voltages above 5 volts.
Well, what's great with the Raspberry is that you don't have to use transistors to switch like you do with an
This does it
Arduino.
all.
You could use
Yeah.
This does it all.
the $20 relay thing that goes with it. What do you call that? That part that goes with the Pi? The relay?
The relay. What do they call it? Relay module.
relay
8-channel
module.
relay module.
8 channels. Eesh. Nice. Digitally controlled.
Yep. Plugs all into your. It comes with the wires and everything to plug right into the Pi.
Well, hey, there you go. There you have a. You're able to switch.
Yep.
With that, you can switch my circuit easily.
You can do anything with this
without having to go through a whole mess of transistor
Bullshit.
wiring and all that.
Yeah.
No soldering either, because it's
Yep.
right. It's
No
a relay.
soldering. Yeah, it's plug and play. It's all plug and play.
That's handy.
Yes, it is.
When you got to
So,
do
Mike-
experiments by desoldering and resoldering and
Are you talking about using the Pi as a replacement for the Bedini circuit? Because that would actually be useful for...
yeah, no, you can. Yes, you can. You
reducing
can
the
use it to
size
act
for
like
the
a
circuit.
transistor. Uh-huh.
Yeah,
Yeah,
because
you
right
could
now
use
the...
it.
Okay.
No, any switch
That would reduce it
is
quite a
the
bit.
transistor is just a switch. It's a relay is a switch. A transistor is a switch. They do the same thing. They just have different ratings on their what they can handle, what the switch can handle, speed-wise and amps and all that.
I'm just gonna scoot up for a quick cigarette. I'll be right back. All right.
But with the Bedini thing or anything that's flying back, you want to use not a transistor, or a microcircuitry device like a transistor, because that flyback is always going to get to that transistor, because it's just the nature of these microcircuitries. They're real sensitive to high voltage. But a relay, it's not going to get damaged by flyback, and you're going to be able to keep your system running the way it's ran when you first started it. As where with a transistor, it'll run really good at first, and then the flyback is hitting it here and there, and it starts running less good over time, and you're like, what's going on? You think everything's fine because everything's running, but it's not running as good as it was when you first started it. Well, that's because the transistor got slightly damaged, but it still switches, but it's slightly damaged.
I noticed that happened on one of the channels of my stereo amp. It didn't fully just die. It just got reduced and then it died.
That's what the flyback does, stuff like that. If it don't totally burn it out, it slightly damages it. And I've noticed if your transistor gets slightly damaged by the flyback, it seems to never burn out. It just keeps running slightly damaged. It's weird.
Yeah.
Whereas other transistors will just stop running altogether, or they'll stay closed or stay opened or whatever. But a relay is not susceptible to that, because it's a spring controlled relay, or it's controlled by a small magnetic field that moves a piece of metal, and you can't really damage that with flyback.
Interesting. I didn't know that.
It's not a microcircuitry; it's a relay.
Yeah.
You guys want to have a little fun?
Oh yeah.
Oh, okay. Check it out. I got the back off of this thing.
Oh. Oh.
We'll light
Is that
this
an
thing
old
up.
tube TV?
Yeah, time to get a little high voltage going.
I'm peeking under the skirt here.
And that coil on the back is the flyback coil that captures the reverse polarity signal of the coil that's running the TV when you turn off the TV. It does that. And if that coil's not there, it would blow up the TV, which has happened in the past.
Come on now.
But the TV has to be running for a long time. Usually.
Oh, I hear something.
Please tell me you got that thing unplugged from the wall.
Oh!
Yeah, baby!
Woo!
We're playing and finding it out! Hell no, I don't have it unplugged.
Oh, wow.
Oh, yeah, it's going to be a good one.
Ooh, that was good, Ark.
Is that a magnet?
Oh,
I
man.
don't know what that is. Honestly, I don't know what he's doing, but it's
It's
cool.
just the flyback, man. That's how you do it. Hold on, let me turn out the lights. Let me see if I can't get this thing going.
Mike is missing the.
Have you ever tried hitting a magnet with that spark? And you get any reactions from a magnet?
Nathan, what is that thing you're holding with
Oh, shut off.
The transistor blew.
Sorry, it popped it.
It's dead.
The ultimate way is to have your circuit set up where you can just plug the transistor
There we
in,
go.
and when it burns out, you can unplug it and plug another one in.
Are you on?
Yeah. That's why I like the breadboard. I can just unplug it.
But even the breadboards, those terminals, they don't last very long. They have
Oh,
these
shut off again.
something else that does the same thing. It's
That doesn't want to stay on right now. It just keeps popping off.
what is the thing you're holding towards it? What is that wire? Instead of what is that?
that's
I
the
don't
end of the
think he has
coil
his
that's
headphones
generating
on
the
right
high
now.
voltage.
He might have took his headphones off. Maybe it's a magnet.
Low
He said it's a
current.
flyback. I'm not sure. It looks like a little magnet, maybe. He's creating some kind of spark gap.
Phil's on Pluto.
Hey,
They keep
What was
sh-
holding towards it in the clamps? Was that thing? Is that the end of the wire or is it?
Oh, so your TV has this thing that goes in the top right here, right?
Yeah.
Right here. This is your high voltage line right here. Okay, it comes off the top of your flyback.
Oh.
So this wire right here is the grounding wire for your TV.
Okay.
So I'm just short circuiting it right there from the hot to the ground.
Okay.
And it makes all the sparks. So when you set up your spark out, that's all you have to do. Now the cool thing is when you have a remote, you just push the button and turn it on and off whenever the heck you want to, and you can start getting voltage that way. The only thing is that it heats up the circuits underneath. That's why they shut off like that. So it's better to pull out the flyback and use it that way. But that one's a good one. So you could tell by the amount of plasma spray you get. So at 1.5 inches, if I start to get a nice hissing sound, that shh, that's exactly what you want. As you pull it towards it a little more, it'll start to spark, and then you pull it away, it'll start to go because of the capacitor size in there, and then you'll get a nice long arc. And I want to say they're about 4 inches long at the longest right there. So that's a good flyback. That's going to work out really well for what I'm doing. So
That's awesome.
yeah. Well, what are you going to do when you got stuff in your garage like that? Don't ever leave something like that in my house. You ain't getting it back.
We enjoyed the fireworks, that's for sure. Those some cool arcs.
No,
Yeah.
and myself, I get all this equipment. I did all my tests, but I kind of lacking. I want to move on to the next step, but I need imagination, man. I need
Let's talk
your
some physics.
advices.
Phil,
You
let's
need
talk
magic
physics.
mushrooms, Phil.
I'm not a physicist, but I could definitely debate this stuff, okay? Because I have some physics. I'm a physical being, and I understand physics for that very reason. So I understand you're trying to get these calculations going to get your gravity, the amount of gravity field generated, right?
Well, he's working on the amp side, so it's a little harder because he's got a lot of heat. So it's only goes like a minute before it has to cool down because the massive amount of heat there, right?
Right, but
Talking
he's
about
got
the
he's
liquid
got
metal
calculations going on to figure out the amount of gravity generating from the device, correct?
You're talking about the liquid metal vortex?
Yeah,
Yeah,
the MHD.
yeah.
You're trying to calculate exactly how much the
Yeah,
gravity.
but it's very simple because I figured something else this week. The gravitomagnetic energy that it generates is exactly the same thing as the kinetic energy. So you know the kinetic energy is the energy you
Kinetic
gain when
energy
you
is
move.
momentum or whatever.
So the energy you gain when you move is exactly the same as the gravitomagnetic energy. So I link the two together and I get the same equations. And it's really simple to understand and it makes sense. You have an object that moves, it gains energy, and it's gonna emit more energy, and that's exactly the same thing as kinetic energy.
An object, well, if it's moving, let's say an object like, here we go. We have a stone. It has 10 pounds of matter.
It's the dielectric. You're trying to increase the dielectric. You're trying to take something that is non-magnetic and making it have a magnetic signature to it. You're trying to increase. How do I want to say this? You're trying to overload it.
You can look at it.
You're trying
like
to
that,
saturate it. When you reach the point of saturation, you get force. You're trying to amplify that force. We're not talking
if it's the dielectric.
you
Here's
don't.
another argument.
Stop.
If it's the
You
dielectric,
don't want grams of force. You can get pounds of force easier with high electricity versus high current. Okay, it just works that way. That's why the power lines can move together. They're always attracted to each other because the dielectric's so high. It has nothing to do with the amount of amps in it because there's very little. It has to do with the amount of volts in it. And once you can get that object in the center, now you can multiply it. Now you'll start to understand T.T. Brown's capacitor because he's taking it such a high dielectric in order to get it. He's putting like a bunch of pounds on that thing. We're talking like he can equal the weight of the whole craft and more. That's what he's doing. Okay.
the dielectric is also dependent on the material and what it can be charged up to.
Yeah, but the whole thing is, look, I don't care what material you use. Okay. Some of it's an absorption material you don't want. In steel, it's real simple. You put the two far apart. Okay. You make sure one's bigger than the other, has more mass, unless you want the center to be completely overwhelmed. You have to put a size difference between the two. You'll get a heavy dielectric and you'll get pounds of force. You'll be able to push way past what you think you can with grams. Trust me when I say that. The effect is so much better because now when you take the amount that's in the center that's not supposed to be magnetic, it's not supposed to be charged like paper, then you can amplify that amount of paper by putting more levels on it. Keep the same diameter, but your thickness is going to be less. So you can take and stack more on there. That's going to amplify the amount that goes into it. So your dielectric is going to be so much higher. Then you're going to be able to pull out way more force. That's how it works. That's how it always works in the lab test. Okay. That's how you can get pounds of force on your scale instead of grams, because you're using exactly what they told you was there. Okay, you can listen to every single one of them when they talk about high voltage lines. It's exactly what they're telling you. They're telling you that dielectric energy right there, when the piece in the center reaches saturation, then you're going to get such a heavy pull force in one direction because one size is bigger than the other. Now, if they're equal, the saturation stays in the center. The part is one's bigger than the other, so it always goes towards that field. There's only one case that it does not. And that's the case when you can actually take a lifter, push it up in the air with weight on it. Okay? And that's a very special state to find. Once you find it, you have anti-gravity. I've seen it done.
He's
Sorry.
trying to calculate for the gravity field that, you know.
Yeah, but you have to use the right equations in the right area to get it. Not everything calculated in what you think it is. That's what I'm trying to tell you. There's a whole different math here when you get to the correct things to calculate. So, sorry if I was being rude.
But Phil, you're using a particular math from someone, right, to get this formula?
Yeah. So
well, I'm using the math of some professor that was calculating the magnetic field generated by a charged disk spinning charged disk. But I just changed the charged disk by a mass, and then it generates a gravitomagnetic field. So I just changed two variables, but the formulas are the same. And yeah, I've got all the maths. It's calculus I copied from some professor.
Right.
So I know I'm right. I know it's correct. And
So you said you found out that two variables are actually the same thing.
yeah, so you have a charged disk that emits a magnetic field. It's the same thing as a massive disk that emits a gravitomagnetic field. So all you have to care about is the gravitomagnetic permeability. You just change
of what? Of what? The area that the field is in? Because that changes everywhere you go, doesn't it? Or is it all the same?
It's relative actually. It's a relative variable, so it changes. It's not absolute.
Right. I wouldn't think it would be because there's different bodies of matter out there of different
Yeah, exactly. But
That's why
densities.
we're talking on the surface of the Earth.
And that's why the speed of light is an arbitrary constant.
I don't even like to draw in the speed of light. Everybody likes to. I don't even like doing that.
Well, this is where
because light's not even moving, in my opinion. It's not speeding anywhere. It's not moving.
So Phil, you changed
emitting
from the rotating disc to the rotating liquid metal, right? Like
Yeah.
this is what you
So
changed.
the only difference with the rotating disc and the rotating liquid metal is the rotating disc uses an angular velocity and the rotating liquid metal uses a tangential velocity because it's going to be like a
Can
spiral.
you describe a little bit the two velocities, the tangential and the angular? Can you help the audience understand what that is, including myself?
So you have a solid disk that is spinning. You're gonna use the angular velocity or the RPM or whatever you want to call it.
If you give it an angle, that is. What if it's horizontal completely? There is no angle now, other than the 180.
So you have a flat disk, and the angle is the amount of the angle. The
amount of the amount of off horizontal. You mean the amount of angle you are off horizontal is what you're saying?
Yeah, exactly.
That is your angular velocity.
Yeah.
And what is the tangential? The tangential part?
Go that
Tangential, yeah, you
Right.
got
So
it.
Lulu, what you're saying is your angular velocity is anything off of horizontal 180. This is 180 horizontal. Anything off of that, you calculate that, and that's like 20 degrees.
Yeah, exactly. Yeah.
More that way, and
That's your angular velocity.
So when you have something solid, you use the angular velocity or the RPM. And when you have something liquid, you use the tangential velocity because it's going to be like a spiral. If you have water or liquid metal, you're going to use the tangential velocity.
So meaning it's not one spin then.
Because depending on the radius, the speed, the angular velocity is going to be different, but the tangential velocity is going to be the same. So it's going to create like a spiral.
Oh, so the tangential is always horizontal? It never shifts?
The tangential is the
vertical?
Yeah, you have a circle. You have a circle. The tangential velocity is the straight line. The straight line, the infinitesimal straight line that represent the speed of a infinitesimal angle. You know what I mean? So you have a circle, and the angle is, if you take an angle is very small, then you're gonna be able to have a tangential speed that is in a straight line.
Oh, a slight curve, you're saying?
Yeah.
Well, liquid vortexes, so it'd be a curve.
Oh, the tangential curve, right? It's a very subtle curve, right?
Yeah.
It's never completely horizontal, or it's a slight curve. It's like
It's
Liquid,
like a
right.
spiral, you know.
It's a
That's
very
what it is.
very small angle on it, is what you're saying. Is the tangential, and it
Tangential
doesn't, and it's not,
velocity
and
is
it's non-variable. Is that what it is? It's non-variable.
well, it's just it's the same. It's the same, but
Stays within the same range all the time within
it's
that
the same
very
for
small.
different radius. You know, it's the same for different radius, but the angular velocity is not going to be the same for different radius.
Like,
You know,
it's
so
because
it's-
more mass vertically,
yeah,
or more surface mass.
yeah. So all that matters is when,
Well,
when
what
you
he's
use
saying,
the,
what he just said there, by the angular velocity of a larger radius would be a lot greater.
no, the tangential
Yeah, it would be,
velocity.
because you got a larger radius, and the same angular
No.
velocity would have a lot more impact.
No, the angular velocity of a large radius is the same independent of the radius.
You're saying that a larger radius with the same angular velocity is going to be the same value. It's not, the amplitude of that velocity is not going to increase with a larger radius disk.
Yeah, it's going to be the same, but the tangential velocity is going to be
It's
different
increased,
for different
increased.
radius.
The tangential increases.
Yeah, exactly.
So the vertical slight
The
angular
yeah
vertical line.
the straight line of the infinitesimal angle.
Yeah. That's the vortex part, the center, right?
Yeah,
The
yeah.
tangential. Or
Yeah,
sorry,
exactly.
yeah. That's nuts, man.
So, but think about it, it's the same. Everybody is afraid every time I talk about the gravitomagnetic force, but it's the same thing as the kinetic force. It's the same. It's the same thing. Something
Yeah, it
that
is.
moves creates energy.
Well, if it's got mass and it's moving, and just because you can't see the mass moving doesn't mean it's not moving. Because mass is not matter. Like gases out there, they're just not matter, but they're gases, so they have mass or whatever. But they're moving. Well, you may not see them moving. They look like just like a cloud of gas sitting there, you know. But they could be moving, and therefore having the reason why they're creating the forces they create with the galaxy is, you know, the
Yeah.
gases is what creates these galaxies. They must be moving.
Yeah.
They don't look like they're moving, but they are.
So yeah, but I think Nathan understood what I meant, and but you got it, Mike.
So you said a larger diameter angular velocity has the same angular velocity no matter the diameter of
Yeah,
the disk.
no matter the radius.
And the only change in amplitude in velocity between the two, tangential and angular, is the one tangential going out the center with the slight less than 1 degree curve on it, which is the center of the vortex, I'm assuming, right?
Yeah, so if you take a solid disk, it's either you take a solid disk or liquid that is spinning, makes the whole difference. Because if you have a solid disk, the angular velocity is going to be the same. The tangential velocity is going to be different.
That's
But
strange.
if
You would think that the angular velocity would increase with the diameter.
If it's a solid disk, yes.
Solid.
Yeah. But if it's a liquid disk, like the liquid metal vortex,
It doesn't. Oh, that's
it's
weird.
the opposite. It's going to be you're going to flip the opposite. One is going to be the
It
same.
decreases.
Yeah. So the angular velocity is going to change, but the tangential velocity is going to be the same. So it's
On
the
the
opposite.
liquid. On the liquid's going to
On
stay
the
the same.
liquid, yeah.
Ah, wow, that's crazy.
Yeah, so the liquid is the opposite.
What do you make of
the
all that?
solid.
I mean, what does that tell you? I don't know what it tells me yet. I'm just going to keep that in the back of my head. But
Well, it's
what does
it's
it
just
tell
to
you?
do the maths and to have because I need to reverse engineer the gravitomagnetic permeability, so I need to go through all the maths.
Why one field? One of the fields doesn't change when it's solid, inverts when it's liquid, and the other field also does the same inversion between the two states of matter. Well, that kind of tells you that the liquid, you're saying the liquid doesn't change the tangential doesn't change with liquid, it only changes with the solid. Is that correct?
Well, you have the angular velocity, the tangential velocity. So one
increases
one
with
is constant.
solid only, right?
Yeah, exactly.
And liquid, it decreases.
Yeah, exactly. No, it's either one is constant, the other is variable.
Right. I
The
got
opposite
that
for
part.
the
Right.
solid and liquid.
I got that part. That's right. And the other is constant. The one that changes, right? That's peace.
Yeah.
So
yeah.
maybe solid matter, spinning matter, is going to be the one for vertical lift. No. Not spinning liquid, because the tangential force increases with the solid matter, not the solid liquid.
But the force is perpendicular to the spinning of the disc. That's the thing.
It's inverted.
It's perpendicular.
I can't remember offhand what that meant exactly, perpendicular.
So perpendicular means
parallel?
Yeah, so perpendicular is the opposite of parallel. It means crossed.
Yeah,
cross.
So
like
parallel
that.
never crosses.
You have a plane, and perpendicular means
But
it's
90-degree
crossing.
angles, I believe. Yeah.
So then they kind of cancel. You can't make anything out of it, right? Because of that. You get it kind
Yeah,
of.
well, that's the anti-gravity force. Anti-gravity is just gravity is just a energy potential. That's all it is. It's a difference in energy. Call it gravity, magnetic, and electric. It all generates a force or an acceleration.
Okay, I have a question. Imagine this in a sphere, like two spheres, one sphere and then another smaller one, but the liquid is between them into a vortex.
Yeah.
Wouldn't that somehow create a magnetic field that could levitate? You know.
No, you need to have a disk, not a sphere, to create a perpendicular force.
Okay, so it's got to be.
If you have a sphere, it's gonna cancel out. It's gonna create a force, and from the bottom, but the top is gonna cancel the bottom. You know, it's gonna do the opposite. So that's why you need a disk. And
you're talking about a three-plate setup, like the thing on the top, one plate, and then another one.
Yeah, so it's all vectors, so you can stack them up and add them up together, and but that's what the TR3B is. You know, that's a vortex of plasma or something like that. But it's almost the same thing.
Right before the plasma state. You want it right before the plasma state.
Sorry?
You want it right before the plasma state. And you want to saturate the center plate. And then you have to pulse it.
Yeah, but plasma is just a more energetic vortex. But I can't do a plasma vortex here at home. But that's.
But it's also using the energy. It's using the energy instead of applying force.
Yeah. But it uses, I'm pretty sure it uses the MHD as well, and to make the plasma spin, but you need pretty much massive plasma. You need the plasma pretty massive,
Yeah, you need the dielectric to be massive. You need the plasma to be almost non-existent because you're burning off the dielectric every time you get plasma. So you're not getting a charged state out of it. You're going to get far less. Every time plasma gets, it uses the energy. You need to use the energy as force, and it won't let you do it as soon as it burns. It's like light. As soon as you see the light, you know that you put amps in it and you're slowing it down. When you don't see the light, it goes much faster.
Yeah.
Sorry, I was just soldering. I got, you guys know I have ADHD. Just making these connections for our breadboard. Very simple. Speaker wire terminal. Solder some Arduino jumpers on there real quick.
I mean, I don't know. I mean, light doesn't travel. It emits. It emits. And that's like not the same thing as, running with legs from one point to the other. It's not. It's an emission.
Yeah. So when you start moving, you gain energy, and when you gain energy, you're gonna emit energy as well.
Yeah, I agree.
Right. Emissions can, get you from one place to the other. But, light is, that one photon did not, go from point A to point B. It emitted itself over and over again from point A to connect in a chain of something, chained it over there as a past emission.
The same photon is never
Not the same emission, a past emission.
It's never the same one that you end up with. It's just a constant transaction.
A radiation, it's an emission of radiation.
Yeah, like one photon is not the same one that gets expelled, like the emission out of it. Where
What I'm saying is the photon that it left the source, it didn't go anywhere. It emitted itself somewhere using emissions, radiations and emissions. It created its signature somewhere else.
Without movement.
Right. Instead with radiation, vibration.
The resonance, yes.
And yes, of course, particles can travel on that wave, just like a surfboard or whatever, or coconut in the ocean. But the wave itself is not the particle. And why are people calling light a particle? I don't get it. Or scientists or
I think you got two different theories crossing right there.
And when they call light a particle, to my mind, they're saying that the light is the coconut in the ocean. It's not the wave itself, which in my mind, it's the wave, not the coconut.
Drowning Penguin on my channel just said, Old Man Builds has an excellent conceptual understanding. And thank you for the subscriber to Nicholas. Appreciate it, Nicholas.
What they call light a light particle,
By the way, some guy on the chat asked me if I needed an up converter. I'm good because I already have a low frequency receiver. So I'm just answering a question from V Sears, I think. Sorry to interrupt.
The best explanation I heard of light coming from the scientific community lately is that it's the magnetic field bending in on itself, curving in on itself. That's where the light gets emitted, where the magnetic field curves in on itself, right at that point.
Yeah, but light's emitted and it travels, right?
Yeah, because it's a particle and it's that coconut riding on that wave in the ocean.
It's all I'm asking.
Light is the wave. It's not the wood chips carried on the water waves. It's the water wave itself. It's not even the water. It's the wave that caused the water to move or to shape itself like that. That is the energy that got the water to shape itself like that into a wave. But it's not the water. The wave is not the water. The water's the water. The wave shaped the water. We all know that's not that's not wrong. That's correct. The water is the water. The wave that got emitted into the water then shaped the water into that geometry. So the same thing goes with light. It's a wave. It's a frequency wave up in the high bands. It's not a particle. And they want to call it a particle wave for some reason. I'm not a scientist to that degree to understand why they call it a particle wave, but they're calling these things particle waves. I mean, how you can even call a wave a particle, any kind of wave, I don't know. Because all waves have no matter. They're just energy.
But it's because it has structure. That's why.
The geometry, right.
The light has structure. That's why they call it that.
Maybe. I don't know. I haven't figured it out yet. But when I hear particle, I think of matter, and I don't think of mass. I think it's matter.
Doesn't matter how much mass it has. It just has structure.
Yeah, but light has mass. It's not matter. It has no matter. Light is mass. It's energy mass. It's not matter yet. It might become a matter and then a particle.
Okay.
I don't know.
Matter is just the result of the virtual particles. I mean, it's just this. It's not like a ball of pool, you know. People see particles like balls of pools that hit each other, and you know, like then that's not at all what it is. Particle is just the results of the virtual particle cohesion. But it's not like a ball of pool. You know what I mean?
So when they say particle, they're not referring to like matter.
Yeah, particle is just a virtual particle that emits a force, and you have a distance and stuff like that. But it's not like a ball of pool that's gonna hit like other balls and and bounce off the border and things like that.
A particle of force, because they don't know what else to call it. It has no matter to it. They got to call it something.
But that's the error.
I guess it's a matter of fact.
Yeah, that's the error that they all claim. Oh, we don't understand why an electron can survive, can be subject to the split experiment.
I mean, you can clap your hands and create a sound wave, and it's a force.
Yeah, it's just the side. It's just like the side effect of the force of a virtual particle. That's all it is. Virtual particle. We cannot see them. We cannot test them. But it's just a force emitted from a virtual particle, and but it's not like a ball of pool. It's just a virtual particle that emits.
I guess when you call it a virtual particle, it makes a little more sense because it's just saying a virtual particle is like saying, okay, the dude over there clapped his hands, the sound wave came over to here, and that's the virtual particle of his hands creating a virtual sound effect over there.
Yeah, I don't think it works that way though.
Well, no, you go from reality, which is the real hands, creating a virtual effect somewhere else from that real matter. You know,
you're just creating a wave, and the energy burn off is your light. That's it. It's the amount of energy used out of the wave that you put into it. That's what it is. Because the wave from the sun still gets to the earth, but we don't see the light all the time. We don't see all the burn off. We get the wave, and the wave interacts with the field around the earth, and when it presses upon it, you get the light. So it's the amount of burn off. That's it, because we don't feel the wave on the ground, we feel the light. So it's energy being used. It shows up in every high voltage experiment you do. And when you can pull that further apart, you'll just find out that there's an energy wave there. And as a matter of fact, I don't even know that it's a wave. It's more like a scalar field than it is a wave. So, yeah, it's just burn off.
I thought a scalar field was just a very low frequency, large wave.
Yeah,
ELF or something.
It's a point-to-point wave. It's more like resonance starting resonance in another Tesla coil. It's simply turning it on by frequency, and that frequency turns on the other one. But it has to be a resonant frequency, not just a frequency. If it was, radio would set off the world.
So you're
The
saying
thing
quartz
is-
crystals are scalar waves? Like, quartz throughout the earth has a lot of, reception with all the quartz. they all
Quartz
wave.
crystals.
So that would be
can-
considered a scalar wave because they bounce and keep going. Kind of like our radio antennas are tuned. They're now scalar
Well-
waves.
Well, it depends. If you can turn on a quartz crystal and have another one turn on in the room, then yeah, it's a scalar wave. But until I see that, I can't exactly tell
Right,
you
right.
that's true.
So two antennas finely tuned with each other is considered a scalar wave.
Yeah, it's an energy that you can't see that's just there and it emits. Now, the two antennas, maybe not. It's a little bit different in that aspect, but two coils with the exact same resonance frequency, yes. Not frequency, resonance frequency. They have to be resonant to each other in order for one to turn on the other in the room without, being that close to each other. You can have them like 10 feet apart and they'll still turn on. They have to be the same resonant frequency. So.
The Tesla coil.
Yeah, they're a little bit more than just sparklers. There's a third kind of energy Tesla came up with, and it's a cold energy. And he said it made his whole body go purple. And I've seen the field. It comes off the wire purple just like that. And it'll light up. Now, as soon as I can get enough of it, we'll see if it goes through my whole body and I'll do it. So, but does it go through the wire and do it? Absolutely it does. Without a problem. And it's cold and it's safe to touch. So, energy's different. You just got to know what it is.
Would you return back to your normal color or like?
God, I hope so. Imagine turning off the lights at that every night. You'd be glowing.
What is that? You'll turn into Barney?
Old man Bill turned into Barney. That's hilarious.
Fidget toy, but it's not a fidget toy. It's like a
nice.
I don't know what you could call this, but it reminded me of a wave, or zeros and ones, zeros and ones.
Nice.
Yeah, this is probably it's a configuration of what a wave could be. All the different places it could. I don't know. I thought it was a cool thing.
So talking about waves, I'm gonna present my. I'm amazed nobody thought about this in 100 years, but to teleport energy, all you have to do. I think I said that before, but all you have to do is convert high frequency photons into low frequency photons of high density, and back and forth. But it's very simple, and then you can teleport energy. So,
What's the distance?
Well, the distance, if you convert the high frequency waves of low density into low frequency waves of high density, then you can travel through matter more easily. So you can go anywhere you want. You're not gonna get blocked by walls or water. So
Okay.
that's the way to teleport energy.
Are we talking like feet, or are we talking about miles, or are we talking,
It was the lower the frequency is the farther away you're able to teleport the energy. So that
If Phil like sends us energy from Canada, let's say like to Houston or to Florida or to yeah, I mean that'll be something.
no, but you guys understand what I meant. Nathan, you got it.
Long range frequencies versus short waves. Long range.
High and low density back and forth. So it's really simple, and I'm surprised nobody thought about this in 100 years. But I'm gonna talk about that because we could teleport energy from the sun, teleport it anywhere on the world. It's pretty cool, you know. It's like we can't. We're not gonna complain anymore that it's cold or blah blah blah. So
it reminds me of the radio they came up with that they said was like teleporting. That you could stand in London and stand in the U.S. and you'd be at both places simultaneously. So, yeah, I forget the name, Thompson or something like that radio, and it had to do with the rotating field that he created in it. So it's probably not the same thing you're talking about, but it just reminded me of it.
Oh, yeah.
Was it riding on the magnetic field?
From what I understand, it was riding through the ground, and the energy goes right into there.
Oh, okay.
So I could be mistaken on that, but I just remember Alexander Radio. There you go.
Because with the magnetic field, like the Earth gets bombarded with a lot of solar flares. So every time like it gets hit, it creates a magnetic flux around it, but it touches at 2 points and then releases.
That's because the Earth has a lot of iron.
So if the signal's riding on that, yeah, that would be correct. That it's existing in 2 places on Earth, because it does 2 places and then it releases. That would.
The sun, when it ejects that energy, it hits the iron core of the Earth, and all that flux is created. The energy from the sun hits the iron core, just like an electromagnet. The wire sends energy to the iron core, and the core generates flux. Iron is very magnetic. I don't know if it's the most magnetic metal in the planet in the cosmos, but on the planet, I think it is.
It break the solar flares break the magnetic field, and that's
right, and then they hit the core of the Earth and generate more fields through the iron core that the Earth then shoots out again.
Yeah, I don't know that the core of the Earth is actually the ball of metal they keep saying it is.
Well, if it is, it would be. If it is, it would do that.
More like a resonance chamber.
Yeah.
Well, you figure they built that model of Saturn.
Even if it's a resonance chamber,
it gave it everything it was.
It would still absorb if it was a resonant chamber, it would still absorb the field from the sun, and then eject it out some other different way. But eventually, it'll capture and release, just like any material would capture energy and release it later, as it does in its natural material state. Iron is really good at capturing energy. It seems like energy. I don't know. Creates a really strong magnetic field when you charge it with a coil. Iron. You could do that with copper and get very weak magnetic field. Do that with aluminum and get it.
Oh, I don't doubt that there's a heavy magnetic field around it, causing the rotation that goes on from both the top and bottom of it.
There's definitely a lot of iron in the core somehow, either in crystal form or whatever. Iron.
It doesn't always have to be iron. It could be bismuth, which is basically just magma, and that could be just the flow of magma doing it. The heat around it could be creating it, and because of that, it gets rotation.
I heard bismuth, it inverts whatever magnetic field it sees. That's what I read about bismuth.
I wasn't talking about bismuth. Basalt.
Oh, basalt. That's a rock. Yeah.
Well, yeah, but it's also magma when it's in,
Well, Right.
But
It
in
has
the
iron, right?
volcano.
It has a lot of iron. This one, I think.
Yeah, and it's got a lot of magnetic field around it. Natural magnetic field, not the kind we induce.
Well, we also have iron.
No, I get it.
And you know, it's very important for our biology. Without it, the hemoglobin can't get oxygen.
Yeah, well, resonance chamber puts off an awful lot of heat. I mean, a massive amount of heat. So you're going to get magma everywhere.
So I gotta get going soon, but I had an interesting update before I leave.
Yeah, we're going to be signing off soon, very soon here. Any last words?
Well, I soldered that terminal connection to provide a more solid connection between the speaker wire and the breadboard for the reference circuit. I had a suspicion that's why the mini board was not working correctly for the reference circuit, and that I was correct. So the system is working flawlessly now. You see the reference circuit shine brighter when it's not in resonance at like 60 hertz, and then opposite happening for the output when it's in resonance. But an interesting thing I noticed at 60 hertz, instead of the lights blinking, they were solid. So that denotes to me that there's some kind of smoothing application happening where it's smoothing out the signal, you know, like, and if some amps do that automatically, maybe the mini board has something built in. And that might be why we're not getting the perfect signal that we got on the Technics in the stereo, the Insignia stereo. So I thought that was relevant.
Excellent. Well, guys, I think we're gonna square it up for the night. It is getting late. I'm sure everybody's getting a little tired. Yeah, our live chat tonight was awesome. We had a really good live chat going tonight. A lot of questions.
Just one sec. We're not done. We're not done yet. I want to talk about something.
No, go for it.
Yeah, right here. The Dyson Sphere. Have you heard about that?
Yeah, the Dyson Sphere is supposed to be able to use or harness the ability of the sun, or the energy of the sun.
Yeah, definitely. So, can you imagine if you collect the energy of a star, and you teleport the whole energy to anywhere you want, like on your planet or something like that? That would be extremely efficient. So I think that makes sense that the Dyson Sphere really exists.
Maybe there's one inside the Earth.
That would make sense.
Yeah, but the star would be more and more effective.
We would become a civilization type 2 or 3. You know, right now we're not classified as, you know, we don't have a number.
Where do they get all the metal for the sphere?
I don't know if it's metal. I think it's some other material, right?
Yeah, I have no idea.
That's a lot of mass.
Yeah. Maybe it's a chicken and egg thing, you know.
Honestly, I think this Dyson Sphere is just a big distraction. You cannot close off the energy output of a radiating star. You have to let it radiate.
I mean, that'd be the size of a planet you would need to make that around that. And if you took in the whole solar system, my God, how many solar systems are you killing to do it?
Maybe the Dyson Sphere is not exactly closing off the radiation. It's just graphing it and letting it radiate somewhat and capturing the rest.
It doesn't have to be full coverage. It could be like a net, like a net kind of.
Well, it is a graph of some kind, right?
You know.
Even that's a lot.
Remember, we've got a lot of asteroids out there.
Well, the theory about the Dyson Sphere, from what I remember, is that you're going to use like AI robots to build it. You know, like robots that replicate themselves to make the sphere faster, and they just go under rocks and harness materials to replicate themselves to then go
Terminator
build the Dyson
asteroid
Sphere.
robots. Is that what we got?
No. The concept of making the Dyson Sphere was to first develop AI robotic and then replicate itself. Little miniature builders.
No, I get what you're saying.
They can launch out there to land on rocks to get the materials that they need to replicate themselves, to then use the materials from the rocks to build the sphere.
Search
And do it
the,
all
not
like
included.
on automation kind of thing, you know.
search the Kardashev scale. I'll tell you
Good
all.
luck with that. I mean, as a technician, I can tell you that. Good luck with that.
They're gonna be the asteroid trash men. They're just gonna keep taking
Go build your Dyson
reusing
sphere
the trash out of the asteroid
with AI
make a
robots.
Dyson sphere.
Like if you use the Kardashev scale, it'll tell you exactly, what type of civilization and in how many years we would probably achieve that.
Oh, I think that thing's broken.
You're talking.
They're putting goals on there that are not realistic in science.
You're talking the efforts of multiple civilizations.
Talking about
throughout thousands of years of our timeline.
They haven't figured out how resonance works. Are you sure that they can
We
even
can't
get
even
there?
last,
We
50
get
years.
great wireless energy just by resonance, and they can't even figure out how to do anything else. There's no way that they got the math correct to do that. They don't know what type
You
of
would have to
civilization
have
it
a
is.
robot do it. You'd have to have a
Man,
machine.
that's just smoke out of their butt.
If you think about it, we already have the International Space Station in orbit. Why don't they just start building off of that? Because it's already in orbit. It's already rotating. It's already, locked in that orbital. That.
Because all the technology that's significant for actual space exploration and civilization is all black budget. It's all kept from the public. They just want us to live in this facade where the International Space Station is the best we can do, and there's nothing we can do about it.
Oh, that's a total lie.
Spend our
No, I know.
all of
But
the black.
it's sad. We lost the technology to go back to the moon. Oh.
Yeah, how
Yeah,
can
right.
you do that? Like, how do you do that? That doesn't make any sense whatsoever.
That's a
No,
lie.
the public's not buying it anymore. They're not buying it.
Do you think the public would approve space programs or wars? Which one would actually say, okay, this is what the public money we want it to be spent on?
They want wars because wars is gonna increase our deficit, and on both side of the war is gonna increase our deficit, and that's what the banks want.
So
They
is
want
that-
us to pay interest off of their deficit.
But so is asteroid mining. I mean, those things are like have precious metals in them. We could bring them back to Earth.
Yeah,
and-
hold on, but rich people want to thin out the population, so their way of doing it is starting wars and killing regular folks like us. That's what
still
they
need
do.
labor power,
They want
though,
population control, and that's the way they do it.
Yeah,
So
that's
it's really
true.
not about money, or it's not about anything. It's just population.
Yeah.
That's what it is.
Innovation is against their agenda, so they're doing everything they can to slow us down. Because innovation breaks the vicious circle of us being in debt all the time and paying credit cards and
Hey,
deficit.
hold on.
and-
You don't hear nobody complaining about population control up in Siberia, do you?
Who cares about Siberia? They get a hold of all the nations that are big, and then they kill people.
Put this whole population control thing in the garbage with that
Yeah.
statement I just made.
No, they
Let's all sit around our igloos and talk about population
War is
control.
not about population control.
That's
it's
it.
about
That's real
land
smart.
and territory, like it always was.
It's
all
population.
about the money.
land and territory.
Now,
Hey,
all
like,
about
and let me go
land
get
and
my
territory.
Indian buddy. We'll sit in front of a campfire and talk population control. Yeah.
They
No,
want
I
you
don't
to
think so.
it's population control. That's a way of control, putting you in oppressed
Ugh.
modes.
Yeah.
No, it's about land and territory. That's what war's about. Land
No, it's
and
not.
territory. Yes, it is.
Control.
The control
It's
of
about
land
control.
and
You
territory.
also have multi-billion-dollar corporations
This
that
land
are
was made
only
for
making
you and
profits
me.
when there's times of war too. So they like to, make the
That-
money.
That's why BlackRock control each and every one of the defense companies like Lockheed Martin and all that.
And it's
That's
unfortunate
all they
because
care
if you're
about.
public, if
Yes,
you're publicly
all you
traded or
gotta
beholden
do-
to a shareholder, that's legally binding.
Well,
All
that's
you got to
corporate
do
territory.
is follow,
there you go again.
follow the money. Follow the money.
Exactly.
And find out.
It's all
Follow
about
the money.
Go ahead
it's
and
all
try to
about
make a
science.
soda.
It's not about science.
Sorry.
It's not about biology. It's not about pharmaceutical. It's not about entertainment. It's about money, man. That's all. That's all.
Again,
Follow the money.
And for me, it's about these nice fat diodes. Look
Follow
at
the
that.
goal.
Those are like 2 amperes right there. No?
I like me a
205
fat
amps.
bottom.
Pen's only going one way, buddy. We get it.
My feelings
may
will
not
not
enter
be
here.
reciprocated.
Money is paper, but what backs money is gold. It's follow the gold. Where is the gold going? That's, who's behind it all.
Oh,
It's
Well, the
never-
gold, I heard that, Bulgaria has sold all their Bitcoin
Oh.
for gold. Britain,
That's a 10
Britain, I think Britain bought a bunch of gold now.
Remember, gold.
Anyway, we're going down a big rabbit hole here. We'll
No,
save
but
this
the
for
East has
we'll
been
pick
buying
it off.
gold, yeah.
We'll pick it off next Friday because I know we could go on with this for another 2 hours. But yeah, it is getting late. Next Friday, 9 o'clock Eastern, we do our live show again. Thanks again to chat. You guys were on fire tonight. That was really good. I tried to post as many of the messages I could on the main screen there. And don't forget to check out Old Man Builds. Don't forget to check out Benefactor. Also, Philip, your what is it, 4X?
Fornox.
Fornox, yeah. And Mike does his YouTube channel as well. Nathan and Ben, they do live shows throughout the week, so please check out their channel, subscribe, and share as well. And I also post all these shows that we do live on the Facebook news groups, so it helps generate a little bit more traffic for each of our guests on the show, and hopefully that gets the popularity up and I'm starting to notice numbers getting better and better as far as how many people are tuning in, and that's good. So it's working. So we'll keep at it.
right on.
All right, guys.
You
Have
guys
a
keep
great
spreading
night.
the word.
That's right.
Thank you.
Subscribe, share,
Good night,
and
folks.
also support all these guys. Old Man Builds, Ben. Support everybody on this channel. And yeah, we'll be coming back live every couple of days. We'll be doing live shows. So, anyways, guys, thanks a lot. Have a great night.
Good night, all.
Thanks, guys.
All right.
Appreciate it.
Take it
Thanks,
easy.
everybody. Thanks, Mike. Have
Yeah,
a good night,
take care.
everybody.
Take care. Bye bye.
Remember, if you like my content, please consider subscribing and hitting the like button on my videos. Comments and any form of engagement dramatically help us break through the YouTube algorithm. I also have a website with research on the Thunderstorm engine, plasmoid technology, and do-it-yourself guides for Malcolm Bendel's retrofit, courtesy of Jordan from Alchemical Science and the Martin Fleischmann Memorial Project. Check out my store for exclusive merchandise along with our forum, where you can post questions, share videos, and join in the community to help destigmatize all forms of forbidden knowledge. Don't forget to check out Jordan's channel Alchemical Science and Bob Greenier from the Martin Fleischmann Memorial Project YouTube channel. They're on the cutting edge of cold fusion technology. More updates on that coming soon. Stay tuned for a new episode of the Soul.
In the depths of hidden files, trapped inside the secret circuits, unraveling through the miles, oh, truth was masked by coded curtains. You didn't know, we're shattering the silence, feel the power, revelations on the rise. torches, breaking through the veils of dark. 0 points and gravity converge, yeah. Guiding voices, revelation starts. Ancient whispers call. They're begging us to open our eyes. We stand tall, defying all their lies. Living in now, we're shattering the silence. Feel the power. Revelations on the rise. Forbidden knowledge we dare to see, unveiling secrets, setting minds free. In this epic we play our part with fearless hearts. And now we're shattering the silence. Feel the power. Revelations on the